Yeah, so I did 14-hour streams, and since YouTube doesn't let me stream for more than 12 hours, I just ended the previous one, and here's the new one. I'm like self studying, but I'm like, I think I'm gonna die. It's too much of chapters, bro. Tomorrow is my test. I'm gonna die. Oh my gosh. Yeah, it's my first drop. What am I supposed to do? What am I supposed to? Oh my god. KB education, bro. Where did that come from? Man, I'm like seriously about to die. Oh man. If you can like hear the TV, please ignore. But like, I'm like, what am I supposed to do? Somebody help, please. I'm so sad. I don't know. I'm like very not well. I mean, I don't feel great, and it's like a lot of chapters. I'm like, tomorrow is my test. I don't know what I'm gonna do. I need Gemini. Gemini, please help. Gemini needs to help me, or I'm gonna like die. If you Again, if you like can hear the TV, please ignore. Like 03 at Gmail. Couldn't find your Google account. Are you like for real? Only bio left. No, I mean like physics is also there, dog. Like I, I can't do it. Like no matter how hard I try, I just can't score well. Like every test I take, it's just the results are not great. I'm just like so tired. I know I'm not gonna score well this time either. Let's start physics. What? I know, but bio is scoring. Not now. Check your phone. Oh, come on. I didn't want to do that, dog. Try another way. Yes, it's me. Oh, come on. You know what? Let's do physics. Yeah, bio is boring, but I mean it's like very scoring too. But you know what? You know what? Let's do it. You know what? I have a great plan. I mean, I need to talk to Gemini first, but like, I think I can like pull this off. Like, I think I can. Like, you know what's my plan? Like, I'm gonna like ask Gemini to like give me all the main formulas, and then I'm gonna go to the PYQs of like 2025 and 2024, and that's it. And that's not a single one thing more thing that I'm gonna do. And like, let's see what happens. Yeah, let's see what happens. I'm gonna make a formula fucking sheet right now, and I'm gonna focus on the main formulas. Let's see what happens. Let's see. Let's see what we got, okay? Let's go. Hold on, like, hold on just for. Okay, just give me 1 second, okay? I need to, like, log in my account in, like, another device so that I can, like, talk to Gemini. Just give me 1 second, okay? Oh, how was your exam, though? Today was your JEE exam, right? How was it? Come on, work! Yes, quite good. Oh my god, that's a great news. I feel so good. Okay, that felt nice. Hmm, but I don't know what I'm gonna do. Okay, I'm sorry, but my sister is calling me, so I'm just gonna have to like just give me like 2 more minutes. Oh my god, I'm losing so much time. But I've been like studying from like 7 in the morning, and whoa, it's already been like more than 15 hours, I guess, like 14, of course. So Okay, I might not need it anymore, so I think we're good to go. Yeah. So yeah, let's do physics. That's what I was like thinking. Let's go. Okay, I feel like so much better all of a sudden. I don't know why, but okay, we got this, girl. Okay, I'm gonna like invite Gemini to like join us. So we have like all these. Okay, can you like see my screen? Okay, of course you can't. But hold on. So let me like share my whole entire screen with you. Hold on. First, um, yeah. Oh my gosh. Oh my gosh. 1 second. Okay, let's go. Gemini has joined us.
Are there specific concepts or formulas that are confusing you? Sometimes just breaking it down can help.
You know what? I think I'm gonna like start with mechanical properties of solid. Okay, I'm sorry. I know I probably wasted like a lot of time, but I needed to like grab my sheets. Okay. So here's the plan. Okay, I'm gonna like go over it again. So first, I'm gonna like revise all the formulas. I'm gonna write them down on this paper, making formula sheets for every chapter. Okay, and then I am just gonna do the PYQs of 2024 and 2025, and that's it. And I don't know who unsubbed me. Guess they're lost because, anyways, yeah. So, and thanks for asking me how I am today. I actually am not really well. I'm really demotivated, but suddenly I feel motivated again. Anyways, let's go, okay? First, we're doing mechanical properties of solids, and then we might just do liquids, okay? We have like a lot of chapters. Let's see how much we can do and how fast, okay? And we have like till 6 in the morning, and okay, we have less than 10 hours, I guess. So let's go.
Stress
Hey, shut
equals
up,
force
shut up,
over
shut
area.
up.
Sigma
Oh my
equals
god.
F over A.
Okay, I was like,
Strain equals change in length
ignore him.
over
Okay, I was
original
like saying,
length.
should I like
Epsilon
do
equals delta
Aduniti
L
or
over
like,
L0.
should I
And
like,
Young's modulus E
what should I
equals
go?
stress over
I
strain.
should do like
E equals
Aduniti
epsilon over
for,
epsilon.
or like
Are
simply
there any routes you want to
concise.
explore further
Concise.
before moving to
Whatever.
problems?
Oh my gosh. Gemini needs to shut up. Try again. Okay, there's like some problem with my internet. I don't know what, but yeah. Should I like go with Aduniti? I think I should go with Aduniti. And I am going with Aduniti. Let's go because okay, we can like also do the simply science one. Okay, mechanical properties of solids revision. Yeah. Let's go. Okay, let's see what's work. Oh my god, 13 minutes. That's like so less. Okay, 20 minutes is like also not bad, but let's should I like do him or 40 minutes seems like a lot, but I don't know. Let's do this, okay? Because I like totally the time. Okay. Okay. Oh my god.
Got it. That's a comprehensive breakdown. Understanding the difference between elastic and plastic bodies, Hooke's law, three types of modules.
Okay, you're like suggesting that I mean like what was his name? You need to for now. Plastic body plastic. Okay. Restoring force. Okay. Deforming force. Okay. Okay. Then it's plastic body, okay. Okay. Okay, stress and strain. These are like two gals for like elastic material. Due to the restoring force, stress is like due to the restoring force. Okay, so we have like two baddies here. First is like stress. Okay, we have like stress, which is like due. If you like can hear, if you like hearing my folks like talking in the background, please like kindly ignore them. Okay, like we're like running out of like light, so like should I like turn this off? I know how I look like a ghost right now. I know, scary, but let's like okay, you know what? I'll just hide myself. I know I look scary, so I'll just hide myself for a little bit till like my lamp gets charged. Okay, and if you can like background, just ignore them. Okay, like they're having a sweet little chat time. Okay, so stress is like due to the restoring force, and the stresses can be of three types. It's normal, it's shear, and it's hydraulic stress. Okay, so it's of like three types. Normal stress equals force by area. It's like applied normal to the area. Okay, that's the area. And okay, cool. And it's the second one is like shear stress. We've all heard about this bad girl. This shit is nasty. Stress equals force by area again, but like, what is the area? Something is fishy about this one. I don't trust this one, honestly. Something definitely is fishy. And hydraulics, like volumetric. It's like also called the volumetric stress, right? Hydraulic stress. Oh no, 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 no! Shut up. Okay. Okay, so I'm like back. So when I like switch tabs to like see chat, the screen gets like black for some reason. So I can't like see chat like all the time, okay? But I will be checking. Okay, so for normal stress, strain equals, okay, we have like strain in the game now. So the strain thingy, strain, strain, strain. Okay, what is strain? It's this equals del L by total L, which is the change in the length, right? Due to the force applied, right? Or like the stress applied. And we have like shear strain, shear. strain, which is like, okay, when this is the block kind of thing. Okay, and then it gets something like this, like a little bit bent, tilted. This is theta, and this is like floor, and the strain equals theta equals, oh, the change in theta, and what's n here? Hey, okay. Oh, it's the height, x by h. Okay, we got it. Oh, we can like find it like through trigonometry. Okay, volumetric strain. Now, volumetric strain equals del V by V. By the way, Ree, don't you like shouldn't you like take rest like you just came after an exam? Okay, nobody is here. Great. Okay, I can like see chat now, so I will know if you're here or like saying something because I have this I have like opened this live on my phone, so like I can like see if you like say something. Okay, Ree, and I don't think you're okay. You're here. Welcome. Is this neat appropriate question? Like, I don't think this is. I think it's like too much. The plug was is that's too much, right? So I think I should just skip it. You know what? Let me like ask Gemini. And you know what? I'm not. You know what? Let me ask what's some neat level question that can like come from this one. What's a neat level question from this? Let's see, like, let's just see, okay? Like, just in case we can't like take risks. Yeah. This is for JEE main or advanced. Yeah, but like, we should actually at least know what's going. I know we're not gonna get deep in any chapter. Okay, we're not going deep. We're just doing the surface level, like just the tips. Okay, I shouldn't have said that, but yeah. What the fuck, Gemini? Come on, work. You know what? Just leave it. Fuck it. We're. Yeah, I'm definitely gonna. I'm not doing this. Okay, yeah, fucking Hooke's law. Hmm. I know this graph is very important. Gemini told me. Hold on. This is the graph, exact graph Gemini like told me about. See, that's the graph, right? Oh yeah, and like it's under Hooke's law, and Hooke says that. Okay, stress is directly proportional to strain. Stress times Young's modulus times strain. Okay, so this is a relation between stress and strain. Okay, we got it. So Young's modulus equals F times L upon A times del L. Okay, we got the. Oh my god, this was easy. Okay, that's a Hooke's law. And this graph is very important, and that teacher is gonna like tell us all about it. And then we have like bulks, modulus, and like some other shit. And I think that's it. That's important. Yeah, I know. Okay, let's enjoy the story. By the way, Reed, thanks for being here. O, A, B, C, and D. Okay. Straight line. It's like directly proportional to strain. Okay. That's called a Hooke's law. Modulus of elasticity. Wait, isn't modulus of elasticity is like Young's modulus, right? Oh, it's Young's modulus for like the length part, and it becomes the bulk modulus for when we're talking about the bulk, right? Oh, no problem. I have nothing to do. Oh my god, thank you so much. Like really, I really appreciate it. You know, I was feeling like so down before. Elastic. Okay, A to B is like non-linear but still elastic. Okay, okay. This is the elastic limit. And above it, it won't follow the Hooke's law, right? Sigma, sigma, boys. Okay, so from B to D, strain is like rapidly increasing rapidly, and if deforming force removed, strain is not equal to zero. Okay, so this is plastic. It's not elastic. That's the plastic zone, right? Okay. Oh, okay. Oh, yeah. Oh, yeah. But okay, if if we like do it like here, no, it's still okay. You know what? I'm not really understanding this, but I think I can like keep all this in mind. So like from zero to A, it's definitely elastic, follows the Hooke's law. From A to B, it's like yeah, it's okay. You know, like yeah, you can like still sit up with us. So it's like again, it follows the Hooke's law, kind of like sort of non-linear but still elastic. And point B is the elastic limit. Yeah, you know, my brother used to say, "कायदे में रहेगा तो फायदे में रहेगा." So yeah, that's what Hooke's law is about, right? Okay, I'm sorry. Next is B to C, and from B to C, it's yeah, we did B to C. Now it's gonna be like from C to D. It's definitely not elastic. Yeah, okay, it's not elastic. It's plastic. It's a plastic zone. That means it's Barbie. And then from D to E, it's something else. Okay. Okay, you know what? I understood everything. What's D to E? Can somebody explain what's D to E is? Like I'm not sure. Brittle D to E are closed, and ductile if D and E are like far. What does that even mean? I don't understand D to E, but I'll just have to like keep in mind that D to E, if they're close, it's brittle, and if they're like far apart, they're ductile. You know what? Let me just draw this fucking diagram real quick. Yeah, let me just, just do it real quick. Okay, this stupid ass diagram right here. I mean, graph. It's not diagram. Okay, come on. Straight line, and then we have a little curve, and then we have like a little more curve, and then we have like something bullshit. A, and like B, and like C, and like D, and like E. Okay, girl. Okay. And from C, you can like literally see that it's like not. Okay. I know you left, I know when you left, okay? You just came back. I know you can't defend yourself. Come on. You know what? I'll just let it slide this time, but just for your information, I know when people like are here and when they're not. It's like it shows how many people are can you know. Okay, let me just write this freaking formula for all of these. So Young's modulus, I already wrote it. And G is for like the modulus of rigidity. Okay, cool. That's like F by A upon X by H. Okay, it's like very easy. Like you just have to like, yeah, I don't think it's like, wow, why did I used to think, why did I used to think that was like something very hard? Del P upon negative del V upon V, or negative V dP dV. Wow, this one's a little spicy. Yeah, this one's a little spicy. Compressibility. What the fuck is that? Oh, okay. Compressibility. You know what? I have a really good feeling about it. Okay. Again, right. Mhm. Wow, this is crazy. Oh, the formula for tension is 2m. Yeah, yeah, I remember. You know what? I think I should probably write that down too, just in case. 2m1 m2 times g upon m1 plus m2. This is like a very common equation. Like, oh my god, I suddenly feel so hot. So you're like gone again. I can see only one person here, and that's me. Wow. Oh, these are like some really good ones. Good varieties, yeah? Okay, so T upon A equals gamma del L by del. Okay. What is A here? What's A here, dog? Whoa, that's the cross section of the freaking wire? the area, the cross section of the string. Wow. Okay, so like, were these the type of like questions that came in your, JEE? Huh? Or like it's a lot? How can you like take it like edge depth? Okay, and that's H, height H, and the pressure is plus rho G H here. So del P would be beta times del V upon V. Yeah, Ree, I can see you. And that's the formula. And so del V equals V upon beta times del P. What is P? What is what is del P? Oh, it's change in the pressure? Is it? Oh yeah, it's change in the pressure. Okay. Del P equals change in pressure. Pressure. Yeah, I know. Yeah, pressure. Yeah, thanks for telling me, but I got it. I'm like a little bit of tube light. Takes time to light me up. And del V equals V times rho GH plus P naught minus P naught, which gives us del V equals V upon beta times rho GH. And here we go. Okay. Whenever you think I am gone in 10 seconds, I'll reply. Okay, fine. Now let's see. Analogy with springs. Okay. hmm Okay. Yep, 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 yep. Oh, yeah, that becomes K. Oh my god. Oh my god, this was like genius. This was so smart. Oh my god. Wow, okay, this was like so great. I need to like unpack everything that happened here. This is so smart. Okay, so we have like a spring, and we're going to use the analogy with spring. You know, force equals kx for like springs, and we can apply the same thing for this these elastic things. Okay, they're kind of like springs, and okay, so and f by a equals dot x by l. Yeah, so F equals gamma by L times A, just like resistance. Yeah, but for resistance, the rules are a little bit like slightly like different, right? Like vice versa. For series, it's opposite. But hold on, okay. So K1 is this, and K2. Oh, okay, got it. This x, so this becomes F equals Kx. K equals gamma. It's gamma, right? Yep. If 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 joined if joined in series, the force equals K equivalent dot x. K equivalent equals 1 by K1 plus 1 by K2. Oh my gosh, that's great. Wow, I love it. Okay, now I think you're gone, and I'm gonna count to like 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8. Oh my. Okay, fine. I lose. I lose. Okay, you're like the potential energy part. Well, hold on. I'll be like right back. Oh my gosh, yeah, we can like compare it with spring. Oh my gosh, we got the formula for the potential energy. Hold on. Let me like write down for the energy density. Okay, energy GY density. Mu, is it like mu or like U equals half times stress? Oh my gosh, strain. Oh, it's like in joules per meter cube. Joules per meter cube. And then we have like energy, E-N-E-R-G-Y energy. U, that looks like potential energy to me. That's half times stress times strain. Oh my gosh, times volume. Wow, that's crazy. Half times stress time. Oh my gosh. So you have like formulas on tips, yeah? So so if I like keep all the formulas on my tip, I'm gonna get it right in physics, yeah? I'm gonna get it right. Yes, I am. Fuck yeah. So U equals like half kx squared 2. So it's like half gamma a lx squared. Oh my gosh, that feels so nice to hear, you know? Okay, seventh is like the elongation, elongation due to self weight x equals mgl upon 2 gamma a. Okay, so if it's like just hanging around, just hanging like this, and its length is a, area is that, and gamma, and then, okay. Okay, got it. Okay, okay. You know what? I'm like damn sure this question is gonna come. This question, this one, this is gonna come. Like it's so right. What? Okay. What? Okay, like this Poisson's ratio, this Poisson's. Okay, this ratio. I have like this is bullshit. What the fuck is this? Come on, I never get it. I never. I never get it. Like I, the fuck is this, bro? Like, come on. What is this? I hate this topic. Poisson's ratio. Poisson. It sounds French, right? It's French, right? Oh, okay. I think I'll just write. Okay, so what the fuck is Poisson's ratio? Like, what is it exactly? Like, what does it even tell? It's like, what? You know what? I'm just gonna write it down and. Okay. Poisson's fucking ratio. Let's see what we got here. So, if we have like a thing like this, and it's like suddenly it gets like longer, and then F, and we have, oh, we're applying F from the both sides, yeah? D plus del D, and this is the elongation L plus del L. So sigma equals, okay, I should just write it right here. Sigma equals lateral strain upon longitudinal strain. What is that it? Wait. Oh, it is. Whoa, okay, you're right. It is. Negative del D by D upon del L by L. You're right. Oh my gosh. You're right. Lateral. Wait. Okay. Lateral. Okay. How come that's this? This is lateral. Okay. This is lateral and this is longitudinal. Strain, right? Yeah. Okay. It's both strains. Oh my gosh. Yep. Okay. And the last and the final thing we have here is this is the last thing we have left. No, I think there's like, oh, that's the last thing. Okay, I'll just have to write these three equations, and then I'm like all set, all done. I'm gonna write them right here. So relation, but I mean among, because there are like three of them, and B is that beta equals gamma upon like 3, 1 minus 2. Oh, we're talking about the Poisson. So this is like the Poisson's ratio. I'm sorry. I just, okay. 2, 1 plus sigma. Okay. And what if I like forget all these equations? What? There's like beta 2 times. Why there's beta 2 times? Oh, in the terms of this and this. Wow, that's crazy. That is crazy. So I feel like eliminate sigma from here. Okay, okay, great. We did it. Shut up. Thank you so much, sir. You were great. Now let's like do the P by Qs. Just like a couple of them. Let's see if we can like do them based on these formulas that we just learned. The maximum elongation of a steel wire of 1 meter length if the elastic limit of the steel and its Young's modulus respectively is this. Okay, we're given the elastic limit. What do we know about the elastic limit, dog? I don't think I do anything. Wait, that's that's the Poisson's ratio. What is going on here? Wait. Okay. What is going on here? I need to understand. This was the Poisson's, whatever, ratio, right? Then what? How did it become the elastic limit of steel? And we didn't study anything about the elastic limit, did we? Come on, speak, dog. We gotta hurry. We don't have time. You don't have time, dog. Come on. My gosh. Are we here? No, it's not. Yeah, I can tell. Then what is it? F equals this times area. When did this happen? Wait, so what even is it? Elastic limit times the area. Okay. And this also equals this. Okay. So we're just gonna equate these two equations. First of all, I did not know anything about this one. So like, okay, I guess we know now. So I should just write this down too. F also equals sigma times A, and F also equals gamma A by L times X. Yep. And this is elastic limit. It's the relation between stress and strain. Oh, wait. Are you sure it's the relation between stress and strain? That's like the Young's modulus. I mean the whatever. Fine, I know it. This equation, so let's just like get it over with. Okay, I got it. The metallic bar of Young's modulus. Okay, we're given the Young's modulus and the coefficient of linear thermal. We are not told anything about the thermal expansion. Oh wait, hold on. No, we're not told anything about it. This is just not fair. We were not told about this equation. Great. This is just amazing. So del L also equals alpha times L naught times del T. Great. Sigma is F by A. Okay. But what about this, dog? Like, who was supposed to tell us about this one? And what the fuck is alpha? So alpha is given as the thermal expansion. This, okay, of course, from this to this, del T is given, and length is given, the original length. Okay, fine, get it. And the Young's modulus is also given. What do we need to even find? The change in length, right? Why was this even given then? What is going on? What is going on here? So this thing is like given to us. What is going on? This thing we found, and then we found that This is this. I think we were given the Young's modulus. Hmm. Oh, okay. We're given the Young's modulus, and we need to find no sigma. That's Young's modulus. There is no way. This is Young's modulus. No. What? No. Okay. Oh wait. Oh yeah. Of course. Of course. Of course. Okay. Wait. Hold on. And like force by area upon L L equals this. Yeah. Okay. This is confusing, but yeah. What were we supposed to find? The compressive force developed. Okay, force equals gamma times area upon the L times the x. What is x again? X is the change in length, right? Oh yeah, that's it. No, it's okay. Yeah, that's the force. Okay, wait, hold on. Okay, so okay, let me just unpack it real quick. No, this one, right? So we were given the Young's modulus and the coefficient of the linear. No, we did this one. Okay, hold on. And then we like found out what did we find? We found what? We found the del L. Okay, we found the del L from here, and from this we got the strain, and we got the strain, right? So now we have the area, we have the area of cross section, and we have the Young's modulus, so we can like easily find. Okay, I got it. You know what? Let me try to solve it my way too. just like once. Okay. So I know I'm like taking a little time, but just let it sink in. Okay, just let it sink in. Oh my gosh, I cannot waste more. I can afford to waste time. Okay. So this is. So we somehow got stress equals del L by L naught equals 0.001. And now force upon area times 1,000 equals what does it equal? The Young's modulus, and the Young's modulus is given to us as 0.5 times 10 to the power 11, dog. That is crazy. So F equals area of cross section is also given 0.5 times 10. You know what? 5 times 10 to power 11 upon like 1,000 times the area is about 10 to the power negative 3. Okay, let's see. So we have like this and this gone. It should be like A, option A. What? Newton's what? No, it shouldn't be. Meter squared. Okay, where did I go wrong? 0.1 meters and then, That's what I did. Okay, wait, what? So this had to. Oh yeah, of course, of course. Oh yeah, 5 into 10, 11 minus. What's 11 minus 6? It's 5. What's 11 minus 6? Okay, something is wrong. 11 minus 6 is 5, but it's still not coming. Oh no, it's 4. It should be. Oh yeah, it's 5 into 10 power 4. That means 50 into 10 power 3. Yeah, I got it. I got it. Fine. Yeah, okay. It shouldn't be like 11. It should be 10 because I did it 5. Okay, I got it. Thank God I got it. Okay, I'm like so happy. A thin flat circular disc of reddish this is gently placed over a surface of water. If the surface tension, why do I have to like mix the concepts? Is this then the axis force required to take it away from the surface is? I have no idea. These questions are so hard though. Like I'm cooked if these type of questions come. We haven't covered anything like this either in these formulas. Can we like solve? Oh my god, like so shit. Okay, great. I did not know about this T axis force equals T times 2 pi r. How was I supposed to know? Great. Water tension the force required to lift of a disc from water equals force equals T times 2 pi r. Is it 2 pi r? It's 2 pi r. Tension. Great. Force equals T times area. But area is like pi r squared. Why is it 2 pi r? Why is it 2? If it's like T times A, then why it's 2 pi r? 2 pi r is the circumference, isn't it? Mm-hmm. What happened now? Okay, first of all, let me fix my hair. Let me fix my hair. Ouch. Yeah, okay, you were saying something. Very quiet now. Yes, so A is not area but circumference. Okay, what happened to my hair? What is that? Oh my gosh, that looks so weird. I ain't got no time to worry about. I'm so sorry. Excuse me for looking like a total shit crackhead, homeless. But I'm sorry. I just can't help. I'm already in a lot of stress. All right, next question. Let a wire. I'm so pissed, honestly. Let a wire be suspended from the ceiling, rigid support, and stretched by a weight W attached. Okay, we kind of did something like this. Like, okay, you know what? Okay, it's like hanging from a ceiling. Okay, there's a weight. Okay, attached to its free end. Okay, the longitudinal stress at any point of wait, we know this. We know longitudinal stress at any point of the cross-sectional area of A. So this is going to be the longitudinal. Okay, longitudinal means downwards, right? It's going to be like because of the gravity. No, it's stretched by a weight at its free end. Hold on, that's the diagram. Okay, wire. Okay. Is it like the one of like that? The tension equals. Hold on. What did it say about the tension upon area equals that? Okay, so we know that T by A equals right. So the longitudinal stress at any point would be T equals, first we need to find the tension. The tension would be equal to the weight. So it's gonna be up. It's gonna be W by A upon gamma. And it's gonna be W by A. Oh my god, I was right! I was right! Oh my gosh, I was right! I feel so good. I was right, dog. Come on, celebrate! I got my first question right. It's a big deal. Okay. Oh, here I had 2022 already. Okay, great. Given below are the two statements. One is labeled as assertion, other is labeled as reason. The stretching. What do you mean, okay? What do you mean, okay? Come on, the dogs are shouting again. You know what? I need to drink a little bit of water. Because I can't shut the fuck up. A coil of spring has more tensile strength than a steel spring of the same dimension. Yeah, I think the reason is correct. The stretching of a spring is determined by the shear modulus of the material of the spring. Huh. The shear? I think it should be like the Young's modulus. Right? No, okay, R is false. I got that right. It's true the stretching of spring is determined by the shear modulus of the spring. When the coil of the spring is stretched, neither its length nor its volume changes. There is only change in its shape. The tensile strength of the steel is more than that of copper. Hence, assertion is true. I didn't get this one right. Should I read NCERT or something? Because I think I'm gonna suck at theory questions. Wow. Really am gonna. Dimensions of stress. Wow, this one's a great one. I think I've memorized it. Yeah, ML minus 1 T minus 2. I've memorized it. I already knew it. Thank you. But this one's definitely gonna come in tomorrow's test. I know it by heart. This one is definitely gonna come. Okay, let's move on. A wire of length L and area of cross-section A is hanging from a fixed point. The length of the wire changes to L1 when the mass is suspended from its free end. The expression for Young's modulus. Okay, hold on. We have done something like this before. So let's just go. a wire of length L. Okay, okay, we have L, we have A, and hanging from a fixed support. Okay, the length of the wire changes to L1 when mass M is suspended from its free expression of Young's modulus. Okay, we know Young's modulus is force by A times L by del L, right? Yeah, so Young's modulus is the force would be mg, right? The force would be mg upon A times L by changes to L1. The change, okay, it was like L initially, and the change in L will be like from L minus L. The L1 minus L, right? I think, okay. L1 minus L. Okay, changes to L1, right? Okay, so it's going to be L1 minus L. We got it. So it's mgl upon A. I think it's going to be B. Hold on, let me check all the options. It's going to be B. And I'm right. I'm right. Oh my gosh, I'm right. I'm right though. ありがとうございます. Okay, thanks to me. When a block of mass M is suspended by a long wire, you know what? I think it's like enough. Oh, yeah, the potential energy kind. Yeah, I don't know about that. But fraction. Oh, yeah, the bulk modulus of a spherical object is B. If it's subjected to uniform pressure P, the fractional decrease in its radius is. Oh yeah, I don't know how to I needed this question because I don't know how to solve these ones. So are you here? You're not saying anything. So I'm just checking the bulk modulus of a spherical object B. Okay, subjected to pressure. Okay. B equals it's B, not beta. Del P. What do you mean okay? What kind why you always write okay? Like what? We times del V. Okay, what? It's del P upon del V upon. Okay. It's the change in the volume, right? So it's gonna be del P and del V by V equals 3 del R upon R. Because it changed the power, right? It's R cubed. The power, okay, I got it. R cubed. Okay. So it's gonna be negative 3 del R. It's gonna be negative del R by R equals P by 3B. Ooh. And then del P equals P. Because del P equals P. Oh, okay. I have nothing to say. Oh, I'm sorry, I didn't see the chat. At least be engaged. Copper of fixed volume V is drawn to wire of length L when the wire is subjected to constant force. The extension produced in the wire is del L. Which of the following graphs is straight line? What? Straight line. Del L versus L. Del L versus L by L. Which of the following would be a straight line, you say? The copper is fixed from a volume is fixed volume is drawn into a wire. When the wire is subjected to the constant force. Okay, yeah. Its volume definitely doesn't change, but its length does. And it's gonna. I didn't know this one down, like, for real. How do you even know that? How do you even know that? These questions are so hard. Did you know? Okay, tell me, could you solve this one? Could you have, like, solved this one? Like, what do I need to, like, do to, like, whoa, I need to plug my phone on charge. What do I even need to do to, like, get better at. Oh my gosh. This one's, like, hard as fuck. Okay, guys, I think we're, like, running out of light again. Oh. This is Young's formula. Okay, we're running out of light again. Oh my gosh, why there's water on me. Okay, so see, the light is, like, going again, and I am gonna look like a ghost. So should I, like, cover myself up again? Or, like, are you okay with me looking like a ghost? You know what? I think I should cover myself up. Because I don't want to, like, jump scare anyone. Okay. So, to not make things scary, I'm just gonna, like, cover it for a while, okay? I hope that's okay. Whoa, the stream is, like, lagging so very much. Hold on. Okay. This is Young's modulus formula. Okay, but the graph pod, like, how do you know if, like, oh man, you know what? I need to ask Gemini. Where the fuck was Gemini, dog? Where are you? Huh. Dog. How the fuck am I supposed to know this? Just give me a quick minute. I'm not very good at questions like this. Yeah, I know, that's the basic formula. And the volume is area times length. Okay. Wow. Yeah. And we just gotta put that in the formula. Man, this requires, like, a high-tech brain. I don't have that. I can never reach to this conclusion that I have to, like, I feel so stupid. Man, okay, I think we're, like, done. Let's, like, move on to the next chapter. Oh my gosh, it's already 12. Okay, which chapter should we do next? You know what? I'm thinking something about, like, Oh my god, I'm feeling demotivated, dog. You know what? I'm thinking let's do like so many. So many. You know what? Just the surface thing. Let's do electric fields and charges. Oh man. This chapter is huge. Let's let's do it. You know what? Let's see what happens. I'm gonna do it, and I'm gonna do it. Hell yeah! Electrostatics, electric fields and charges. Do NEET. Damn right. I know. Okay, hold on. This is very important. You like trick field due to field due to what is it? Due to line charge. Due to line charge. Okay, we have like this finite. Okay, theta 1, theta 2, and E perpendicular would be K lambda by D sine theta 1 plus sine theta 2, and E parallel will be K lambda by D cos theta 2 minus cos theta 1. And like we can find the semi-infinite and infinite using this exact formula. Can't we? Yes, we can. Still, I'm just gonna like write them down just in case the presents can wait. Semi infinite. Okay. Let's see what happens. Theta 1. Okay. Theta 1 equals 90 and theta 2 equals something. Oh, that's theta 2. So it's gonna be what? Anyone gonna tell me? Fine. For infinite, E perpendicular would be 2k lambda by d equals lambda by 2 pi epsilon naught d. Okay, cool. And E parallel would be 0. Thank you so much. I'm going to sleep and I will wake up at 2 a.m. Okay, no problem. You deserve a good sleep. Okay, hold on, wait. Okay, electric field due to a ring. A ring. Damn right. So E equals KQX upon x squared plus r squared whole raised to power 3 by 2. Okay, that's good. The graph at x equals 0, E becomes 0. Okay, so the graph looks something like this. Well, let me like just draw this real quick. E and x and r, and the graph looks something like this. It's maximum at r by root 2 and r by root 2. Yeah? Hold on, dog. Let me write everything down. So for disk, we have E equals sigma by 2 epsilon naught 1 minus x by root x squared plus r squared. Oh, that's a crazy ass formula right there. Yeah, it is. But due to infinite disk, it's gonna be sigma by 2 epsilon naught. Okay. Charge fee. Mm. Sir, wait. Okay. Electric field due to conductors. Due to charged spheres. Electric field due to charged spheres. Yep. Let's see. We just touch. We're gonna just touch the surface, and then we're just gonna come back, just like that. Yeah. Yep. Conductor or solid. Okay. First, if it's like a conductor, hollow, solid, hollow or solid. Out. Okay. If it's like. Okay. That's the graph we have right there. By so much proportional to. Okay. And for a charged conductor, hollow or solid? For a conductor, the charge will always be on the outside. So for R what? E will be 0. I think you did. Oh yeah, R smaller than R, E would be 0. For R greater than R, E would be KQ by R squared. Easy. There's nothing hard about this one, but the real player is the non-conductor. The non-conductor, especially, okay, hollow one will behave the same as that. The solid not conductor would have a graph like this, straight line, and then the downfall. Okay, so inside it's gonna be like for R smaller than big R, E is KQ R by R cube. Or rho R by 3 epsilon naught. Yeah, this one's good. And for R, wow. It feels like greater than R. E equals KQ by R squared. Easy peasy. Yeah. Yeah. Okay, it's gonna be rho by 3 epsilon. Rho R by epsilon naught. Okay. Oh yeah. Oh hell yeah. Out. Type of questions like these on the axial point. Are we talking about on the axial point or like on the equatorial point? I don't know, but we gotta know on a general point. Okay. So, elec- electric field guys, we're back. I am back, and I was like thinking maybe we could like have a little snack. It's kind of like getting cold. It's really like getting cold. Should I like put something on? You put a. That feels better. Okay. Can I like stay in the dark like this? Or do you want me to like turn this bad boy on? Okay, where were we? Yeah, I think we should like do causes law too. Okay, I know these field outside a thin shell. Easy. It's gonna be KQ by R squared, and this one B is 3, definitely. So it can be either A or C. Let's see. C, the field of thin shell at the surface. It's gonna be 2 and C. Damn right. I knew it because I'm smart. Now let's finish this real quick and then we're gonna have our snack. Hell yeah, baby. We're gonna have this. I should like keep my voice low because there be people sleeping here. Anyways, I wish I had like a soundproof room so I could like scream. The field inside a thin shell. Of course I know. Shut the fuck up. A particle of mass m and charge q is placed in a uniform electric field. The kinetic energy of the particle after time t. Huh. The kinetic energy. What do we know about that? I think it's. What do we even know about that? The kinetic energy is half mv squared. It's oh yeah, half q v squared. I guess. Uh, um. What did I miss? Oh yeah, of course. I could have like used this one. So we found the AT from here, and v equals that, and then half mv squared, and we found okay. Okay, understandable. I got it. We got it from there. Okay, wait, who's watching? Somebody is here. Do you want the snack? Okay, let me see. Oh gosh. Ouch. I think it's gonna like. Please don't bruise. Okay, let's go. A metal cube of size 5 centimeters is charged at 6 microcoulomb. The surface charge density on the cube. A metal cube of size 5 centimeters is charged. The whole cube on the surface charge density on the cube. What's the surface charge density? That's sigma, right? Or whatever. And it's Q by, what was that, area? It's going to be Q by, what's the surface area of a cube? That's probably 6 into 10 power negative 6 upon, what's the area? It's a cube. No, that's the volume. 6a squared. Hell yeah. So it's going to be 6 times 5. It's going to be 5 into 10 to the power. It's in centimeters, so first we gotta convert it into meter. It's gonna be 0.5, and then it's gonna be 10 squared. It's gonna be 0.5. That's 5 into 10 power -1. And -1 squared is still -1. You smart. I see you. Okay, I think it's gonna be 6, and then it's gonna be like 10 power -5 upon 5, and then it's gonna be like, it's gonna be 2 to 10 power -4 or 3. It should be 2. Where did I go wrong? I can't like do basic calculations now. You kidding me? 6 into 0. Wow. Oh yeah, it was a squared. What was I even thinking? 6 into 0.5 into 0.5. Yeah. 0.0025. Oh, yeah, makes sense. No, I don't think it does. Okay, I really need to learn the conversions, dog. Like for real. 0.5 meter and whole squared. Okay. It's gonna be 0.05 meters and this whole squared. Oh. Oh wait, yeah, it's gonna be 0.05. And then it's 0.0. It's gonna be, yeah, I got it. It's gonna be, yeah, I got it. What? If this is over a surface, then the number of flux line entering surface must be equal to the most. Yeah, that's true. No, it's not. It's gonna be A, of course. There's no charge and charge. I mean, there's, but like, an electric dipole is played. Oh yeah, the fucking dipoles. Oh yeah, the dipoles. The dipoles. Yup, we gotta do them dipoles, dog. We gotta do them dipoles. Fuck, let's do the dipoles. I think it's gonna be covered in this lecture. Oh yep. There we go. Oh my gosh, hold on, let me draw the graph. Electrostatic potential. Oh, we're talking about the potential. We're talking about the potential. Oh my gosh, you know what? I'm hungry. And I think I should just eat something. You know, my stomach is like already upset. Still eating bullshit like this. Honestly. It's kind of weird. I mean, not written barbecue on this flavor, but it's still kind of like giving try hard barbecue vibes instead of Korean chili. It's 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 giving a little barbecue, but like not the kind of like I love barbecue though flavor. You gotta write this shit down. A shell. Solid sphere. Oh, this one's a good one. 3r squared minus x r squared. Okay. Potential energy. When are we getting to the dipoles? Okay. Q2, then U equals KQ1 Q2 upon R. Mhm. What's self-energy? It's like its own potential energy. So self-energy shell equals KQ squared by 2R. Solid sphere U equals 3KQ squared by 5R. Okay, for some reason, I don't know, but okay. For a shell, it's like KQ squared by 2R, and for that, it's 1 plus KQ squared by 2R. It's just like, yeah, okay, cool. Done. Hold on. And it's like partial differentiation, yeah? Minus dv by dy j cap minus dv by dz k cap. Oh, yeah. Del v equals negative e dot dr. Okay. Oh, yeah. Finally, the dipole. Okay. Hold on, dog. Hold on. Okay. So first we have like a dipole. Okay. Dipole. Kind of like like dipoles. Like this thing was like a little bit. I don't know. My stomach's already upset. I shouldn't have like eaten that. Now I'm gonna regret. I swear to God. At axial point, electric field at axial point is 2k pr upon r squared minus a squared. Oh my gosh, yeah, I remember this formula. E squared minus r squared minus a squared, and the whole thing squared. And this is like kpr upon x squared plus a squared whole raised to power 3 by 2, that's 1.5. It can be like, if r is like very much greater than a, then e axial can be 2pk upon r cubed. Right, right. And e at equatorial would be PR upon x squared plus a squared whole raised to power 3 by 2. Damn right. Uh-huh. Wait, what? No R here? Okay, no R here. Great. So it can be like if R is like much, much greater than A, it can be like E equals PK by RQ. Okay. But direction opposite. Did you get it? Yeah, it will be like opposite to the dipole. Wait, the direction of dipole is like from negative to positive, right? Direction from negative to positive. Okay. So it's gonna be like opposite to that. Mm-hmm. Okay. It's like getting colder. I should wear this jacket properly because I don't wanna. Wait, who is here? It's showing one person is here. I feel dizzy. Oh my gosh, it's like. Can you like turn around a little? Like, yeah. Ouch. Mm-mm-mm-mm. Mm-mm-mm. Wow, we wasted 3 hours. Great. Wow. Okay, so now we have like axial point and like this point and that point. You know what? You know what I'm thinking? Yeah, I think I should try that. You know what? Yeah, I think I'm gonna try that. P here equals 2AQ. P equals 2AQ. Okay. Hmm. But it's opposite in the equatorial point. Huh? Electric field at general point. Yeah, I'd like that. No bullshit. Mhm. Okay. E P cos theta equals 2P cos theta K by RQ. EP sine theta equals okay, K by RQ. E netto equals root E squared P cos theta sine theta plus PK by R cubed root 1 plus 3 cos squared theta. Wow. And tan alpha equals tan theta by 2. Thank you. I'll keep that in mind. S for JEE. What a creative name. Okay. Torque. Yep, torque and potential energy. Very important topic. Sehr importante. Okay, who's here? Cheers, everybody. Let's go. Okay, wait, hold on. Let me check my YPT. Cause no, wait, hold on. Please don't tell me that it's like turned off. Please don't tell me it's turned off. And thank God it's not. Oh my God, it's been almost 18 hours. Just hold on 1 second. Yeah, where were we? What? EP sine theta upon EP cos theta. Okay. Sine by. Yeah, of course. Sine by cos. Sir, come on. Can you like stop for a while? P E sine theta. That's about. Uh huh. And potential energy is just the opposite. Equals negative of P dot E. It's literally the negative of it. Yep. Yep. And that's gonna be negative P E sine theta. Of course. And it's gonna be stable at theta equals 0 degree. U minimum would be negative PE. Okay, that's going to be the U minimum, negative PE. And it's going to be unstable at theta equals 180 degree. Potential energy would be max equals PE. And at 90 degree, potential energy would be 0. Thank you for all this information. It's going to be so useful. Okay, freaking Gauss's law. Shut up. Hold on. How many hours you sleep before 24 hours live? I don't know. I actually okay. So I mean, I think I took a normal sleep. Yeah, but I slept like early, like at 7 or 8 in the evening, and then I woke up at 5. And then from 5 I was like awake, but I started this live on like around 7. So yep. But don't worry, I'm not a superhuman. I have chugged a lot of coffee today, plus some electrolytes. Even ocean dog. I'm like full on stuff. So yep, that's it. Fucking Gauss's law. Okay, Gauss's law. So it's Gauss law. It's like the the equals Q inside upon E naught. Yeah, that's the charge enclosed in E's electric field due to all the charges. Okay. So, okay. Maybe I will also have to study for 24 hours tomorrow. Stay hard. Okay, I will not do a 24 hours challenge tomorrow. Actually, I have a test today, so that's why I'm like staying up. Normally, I do like 14 to 15, like around 14 hours. But like this fucking YouTube doesn't let me stream that for that long, so I have to end the stream before like around like 12 to 13 hours. Yeah, I like streamed for 18 hours once and like it didn't even get uploaded. Anyways, yeah. So like imagine this is thing, and this is Q4, Q5, Q1, negative Q2. So the flux would be Q1 minus Q2 plus Q3. That's the enclosed charge upon epsilon naught. That's going to be the flux. Okay. Wow, this is a solid angle. What the fuck is that? What the fuck is that? Okay, what is that? Wow. Solid angle. Nah, that's definitely not coming in neat. No, that's this shit is like not coming in neat, right? Yeah. Okay, I like need to plug in my before it dies. The conductor. Okay, that's it. We're done. Congratulations to us. Wait, let's just do concentric. I think I know what it is. We need to like do Gauss law like once more, I think. Why'd you delete your message, dog? Hold on, wait. I fucking hate when y'all do this. Yeah, thank you so much. That was like very helpful. Now, should we like do? I think we should do like the kinetic theory. No, we should like do gravitation. Yeah, we should do gravitation. Thank you so much, sir. That was like really helpful. Let's do like let's do gravitation real quick. It's literally the same as this one. Gravitation. Exactly. That's what we're gonna do. Come on. 51 minutes. uh, don't you think it's like a little bit too much? Top 200 cube physics PYQs. Short shot. 7 questions. Gravitation expected Qs. You know what? I think I'm just gonna do this one. You know what? I'm just gonna like do the. Yeah, you know what? Just shut up. I think I'm gonna like use the PDF for this one. fucking hate when y'all like keep deleting stupid fucking messages. Like, if you don't wanna, oh my gosh, just pisses me off so much. So we're doing like gravitation, and we're like doing the main formulas only, like fluid mechanics. We're gonna do fluid mechanics too, dog. Hell yeah. Oh, we haven't done a single question on this one though. Stress and strain. Wow. What is that? Tan 60 upon tan 45. Longitudinal stress upon longitudinal strain. Okay. Yeah. What chapter is this, dog? Gravitation. Oh, right here. Okay, it's not okay. Just the main formulas, and we're not doing anything else. Just the main formulas. Let's see what we got here. Newton's law. Okay, we know that. Superposition. What's this? So if like F net is what is that? Oh my gosh. That's like that shit is like so embarrassing. I don't know, like, is it like the F net is root 3F? So because there's F here, and F here. Gm squared upon A squared. F from here, and root 2 F from here. I don't. A net force on an object is a vector sum of all the forces acting on it. Okay, I don't get it. What? The fucking dogs won't. You can see, like, it's really late. The dog won't stop barking. The superposition theorem. I don't know what the fuck is that. You know what? I think I'll just watch a video on it. The superposition theorem. The superposition theorem. The what? Let me run my fingers through your salty hair. The superposition theorem, gravitation. It's flow head physics. What even is it? Oh yeah, this he's explaining. Oh wait, y'all can't see him. Let me like share. Let me like share my screen real quick. Yep, and that's it.
On the 1 kilogram mass. So we want to find the resultant gravitational force acting on this kilogram mass here. We need to use the principle of superposition. So the sum of the individual effects is equal to the net effect. And so we need to add those forces vectorially. So I've drawn it here. And so we have the force of 2 acting on 1 is given by this force here. And notice the notation. Notice that it's F subscript 2, 1. So 2 acting on 1. This is conventional notation, and your professor will understand what you're trying to communicate when you use it. So this is the force of 4 acting on 1. So the force of this guy on this guy. And then the force of 3 acting on 1. So the force of this on this. So let's just write down each of the vectors separately and then add them up. So F subscript 2 acting on 1 is the following. So it's going to be equal to G. And notice that this thing doesn't have a y component. It only has an x component. So it's going to be equal to G times 2 kilograms times 1 kilogram, and then divided by the distance between them squared. So it's 2 squared. That's, of course, in the x direction like that. And then there's no y component, but we put a placeholder as before for adding vectors, right? And then F subscript 3.
Oh, that's the distance. This one's like the distance.
On 1. So the force of 3 acting on 1 is this guy. And so that one does not have an x component. It only has a y component, and the y component is negative. So it's going to be equal to 0 x hat plus, and it's not plus, it's going to be a minus. Well, plus a minus, but we'll just put minus for shorthand. Minus G times 3 times 1 divided by 2 squared. And that's, of course, in a negative y hat direction. Okay, then the force of 4 on 1. This guy is acting down at an angle like this, so it's going to have components, right? And we know that because this is a square, that this angle here is 45 degrees. Okay, so then the cosine divided by squared. And then the cosine of 45 projects this thing onto the x-axis. So times the cosine, 45 degrees. And that's, of course, x hat. That's the x component. And then the y component will be negative because
it seems like he's struggling.
We see clearly that it's acting downward and to the right. So it's going to have a negative y component. So G times...
Oh my God, yeah, it must be so hard for lefty teachers to teach on board. Like, this is how they're going to write.
4 times 1 divided by 2 square root 2 squared like that, and then times the sine of 45 degrees, y hat. And then we add all of this together. And now, because we were careful to keep the x components right on top of one another and the y components right on top of one another, that's why we put these zeros into places for those components. We just sum down, right? So the resultant force is equal to, and those numbers are, for the x component, 5.69 times 10 to the minus 11 x hat, and then minus 7.36
What?
times 10 to the minus 11 y hat. And that's, of course, in newtons. Did we make it all in? We did. Okay. Should we now find the magnitude of the force? No, because they didn't ask us to. If they asked us to, we would take the square root of the sum of the squares for this guy, right? But they didn't ask us to, so we don't solve for things that we aren't asked to do.
They didn't ask us to do. Wow. Even natives are bad. Is he like not native? Like, doesn't he?
You want to save time on exams. Do things quickly.
Oh, it's a he.
See you next time.
Hernandez. Of course, he's not a native. It's okay. Who gives a fuck? Okay. I kind of got what you were trying to do right there. Yep, I got it. Okay. Let's get back to where we were. Let's get back to that PDF. That stupid fucking PDF. Yeah. Alright. Wow. It's like, wow. Why is it like so... Why is it like so bright? I don't want it to be that bright. gosh, it hurts. Anyway, yeah, let's get back to our PDF. So we understood the superposition theorem. Like, kind of like, not a big deal, I'm not gonna lie. Is it like better? Ghost time. I think I should keep this one on. Yeah, it's a little dim. Yeah. So as I was saying, we got the superposition done. Okay. The G field intensity, I equals Gm by R squared. That's okay. Gm by R squared. Okay. Oh. Oh, okay. That's basically like electric field, right? Yeah. The gravitational field, of course, easy. Find x so that the field at a point will be 0. Oh yeah, those. Wait. Oh yeah, that kind of. Hold on. We need to like get to the electric potential chapter. Where is it? Here we are. Yeah. Yep. The fuck is that? The fuck is that? The fuck is that, dog? This is gonna cancel out. 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 0. Not 0 because something will be there inside. 0 and 0. Huh. 0, but there will be a field inside. Yeah, like in this direction. Yeah. Yeah, and what about this one? It will be like non-zero, yeah, for both of them. I was looking for this one formula. Where is it? Wow, it's literally here. The relation between plane angle and solid angle. Okay, you know what? I think I should like probably write that down. Why don't we get at the down? You know what? It seems important, so I'm just gonna write it down. Relation between plane angle and solid angle. So I didn't even know they had a relation, dog. Like what? So 2 pi 1 minus cos theta. Literally, who cares? I definitely don't. And flux through this is q by 2 epsilon naught 1 minus cos theta. Wow. Definitely don't care. Oh yeah, there will be. Oh, wow. Yep. Yeah, this is the formula. Like charges, x equals d by root n plus 1. Unlike charges, x equals d by root n minus 1. N equals big charge upon small q. Yeah. Damn right. Oh, yeah. Oh, yeah, these formulas, of course. Very important. So, like, T equals root F E squared plus mg squared. And, like, tan theta equals Fe by mg. Great. Yep. Wait, we just gotta know like that. The tan theta alpha by tan beta are like equal to m2 by m1. So they're like inversely proportional. If m is greater than m2, then alpha is smaller. Okay. Inversely proportional, I got it. Wow. Force on a rod due to a point charge. That's gonna sting a little. It's gonna be a kq lambda L upon kq by r. So r and then the other r is just the other r and the other q is just the new r and the new L. I mean the new charge. Damn right. Field due to line charge. Oh. Okay. Wow, that's great. Now let's get back to the gravitation part. Let's go. Let's go, baby. No, we're not doing simple harmonic motion. Like, fuck no. We are doing gravitation fast. That also like the top. Formulas only, nothing spicy. Just the important formulas. That's it. Yeah. It's like those ones. Oh, this chapter is like not very big. So for a hollow sphere, the I outside subside inside. Okay, for a hollow sphere, it's like the inside is gonna be 0, right? Yeah, it's gonna be outside. Yeah, easy. And for solid, the rules are a little different. For inside, it's gonna be the same, but inside it's gonna be a little different. Just like that. Just like the solid sphere non-conducting electric field for this one. It's just like this. GMR spawn R cubed. Exactly like this. That's the same thing, dog. What is the force inside that? Okay. Force inside is just extreme. Acceleration due to gravity, dog. Oh yeah, these ones, well, bro, these ones fucking good. 1, 2, 3, 4, and 5. Okay, this chapter 6, 7. Okay, this one's like gonna be a good one. Wow. Okay. After this, we are gonna do, you know which one? Let me check. After this, we will do fluids. Yeah. And then after that, thermodynamics, current, electricity, motion, and oh my gosh. So many. Definitely like do the Vanya-Caliper formula. Yeah, that's gonna be a really good one. Uh-huh. I don't think I'm gonna make it. Still nothing. You know what? I need to like go to the washroom. I ride in Hollis in Hawaii. I. Don't try to piss me off, boy. Let's go. Come on, dog. Just work. I'm like super fucking pissed. Thank you. You and I ride in Hollis in Hawaii. Back in on a diet. I don't know the lyrics. Okay, this is the important one. I burped, and it wasn't like because I'm like full. It was because I'm like so hungry. It was a hungry, starving burp. Gravitation. I can't believe Stephen fucking Hawkins cheated. I'm like, the Epstein Island. Don't even get me started on that, bro. Wow, that's crazy. Anyways, yeah. Hollow. I know, dog. Hey, shut the fuck up. I know. For hollow and solid, for both, I know, but still, I'm gonna just write it. For hollow, sphere I out equals negative GMR squared I surface equals negative GMR squared I inside equals 0. Solid sphere I out equals negative GMR squared I surface equals negative GMR squared I inside equals negative GMR upon RQ. Damn right. Acceleration due to fucking gravity. On surface, it's definitely easy. G naught. Okay. Acceleration due to gravity. Yeah. Kiss your face, kiss your face. Red hot, red hot. The fuck am I even singing? Okay, first one we have like on surface. Damn right, girl. First of all, Earth's density equals, we'll get to that later. G naught will be G mass of Earth upon radius of Earth upon, equals 4 by 3 pi r G rho. Yeah, and if like m constant, then G naught is proportional to 1 by r squared. If rho density constant, then G naught is proportional to r. Okay. Okay, so if there's like Earth were to be like increase in density by this time, then what? Keeping the mass same. Ouch. By the way, the density of Earth is 5.5 times 10 to the power 3 kg per meter cube. That's it. I thought it's gonna be much bigger than this. Above the surface, okay. if it's like above the surface, GH is going to be G naught R squared upon R plus H whole squared. Wow, that is good. That is crazy. Yeah. And GH equals G naught upon 1 minus 2H by R if H is like much smaller than R. Okay, if height is like much smaller than Earth's radius, and G naught it's gonna be 1 minus 2H by R. Makes sense. GH is gonna be equal to, okay, got it. And now, below the surface, that's gonna be a good one. Now, fucking below the surface. You know what? Today's goal is to perform really well in physics. Do you get it? Yeah. Mm-hmm. Yeah, baby boy, we got it. Let me this salty. I think salty. Okay, GD is gonna be G naught G times 1 minus D by R, girl. Mm-hmm. Percentage change in the G at height H. What? Oh. Okay. Okay. The variation of G due to the shape of Earth. Oh. Okay. Earth RE equals R at poles plus 21 kilometers. GP is greater than GE. I guess everybody knew that. And okay. Mass equals rotation of Earth on its own axis. Wow! I didn't know we had to do this too. Variation of G due to rotation of Earth about its own axis. G effective would be G naught minus R omega square cos square theta. It's like subtraction, right? It's not like times negative. G naught minus R omega square cos omega square theta. Okay. Equator 34% less, so measured from the equator. Okay. Let's go! Okay, the depth at which the value of the value of acceleration due to gravity becomes 1 times the value of the surface. Wow, you know that the depth part is going to be d by r, right? G times times 1 minus d by r equals 1 by n. So wait, hold on. I think I can like solve this one. So g dash must be g by dash. Okay, g by n equals minus d by r. So exactly what I'm doing. So 1 by n equals 1 minus d by r, and 1 by n minus 1 equals negative d by r. D equals 1 minus 1 by n times r. And I'm damn right. Got it. The height of okay, now I don't need these. T equals 84.6 minutes. The Earth rotates 17 times present rotational speed, so the body at the equator feels weightless. Yeah. Okay. Yeah, alright. The rocket projected W. What? Oh, that's a nice one. If time period to like rotate was like 84.6 minutes, that's like 17 times the present rotational speed, then at equator everything will feel weightless. Bro, I'm like studying. I just love talking to myself. Mhm. Love my company. I'm like so fun. I think I'm just crazy. G potential energy per unit mass. Dog, like V equals U by M, of course. Dog. Mm-hmm. Oh yeah, that's the exact same fucking thing we did in electrostatic. Due to a point mass at distance. So are we gonna have like dipoles in this too? Wait, no. If we're gonna have dipoles in this, I'm gonna DIE. I'm gonna die. Wow! The fuck? So a lot of bullshit. The fuck? GPD is a combination of point masses, gravitation potential, due to combination of point mass. Okay. At this P, it would be gravitation potential by this plus this. Minus this. Yeah, like sum of all of them. Okay, let me just write it down real quick. I'm not doing that bullshit. Equator will feel at P equals 4.6. Oh my gosh, so we are again running out of light. So just like plug it in, I guess. Yeah. We're still running out of light. Why don't we get that? Oh my god. 2 a.m. I'm gonna fucking die. It's 2 a.m. What am I even doing? You know what? I'm gonna do this real quick. Yo, what the? Wow, this is gonna take a while. This is gonna take a while. So I don't think we'll be able to like complete most of the chapters before 8. Huh. Yeah, like 6 hours. Time flies. Okay. You know what? In the next text, I'll like focus on like being good at physics mostly because I think I need to score well once in physics, right? And next time it's like easy. You know what? Next time I'll just focus on these two. Oh, I think I can get it next time. Yeah. Oh my gosh. You know what? Next time is the time. Next time it is. I'm gonna get a full 600 plus this next test. Hell yeah. So that will cover like full syllabus as per NTA. What the fuck, dog? so. Okay. I think I need. What do I need? This is not getting. This is not ending. The fuck? Literally same as that, but this one's gonna be different. Oh yeah, baby girl, I know. TP due to uniform ring, same as that. Oh my gosh, we've done everything before. TP energy, total number of terms, it's gonna be n times n minus 1 by 2. I don't think so. 1, 2, 3, 4. 4 times 3 is 12 by 2, 6. Oh yeah, like this, and this. Wait, this. What? 1, 2, this. And this is, oh, yeah. So like 4 times this, and oh yeah, that's how we do it. 3 minus 2, 6 minus 3. So it's gonna be this. 3 times this. Okay. 4-point mashes. Yeah. Okay. It's gonna be like that. It's gonna be this. Right. Longer. So you can't like raise it? Okay. Wait, so it's and whatever that is, yeah. You know what? Let me just try to solve it right quick. It's gonna be 4gm squared upon a minus 2gm squared upon root 2a. So it's gonna be root 2a, and it's gonna be root 2. What's that? 4 root 2 gm squared minus 2 gm squared. Oh yeah. Yep. Huh. I don't know what to do. What even happened here? How is it? How is it that? Wait, 1, 2, 3, 4, 5. 5 times 4 by 2, 20 by 2, that's 10. Okay, 1, 2, 2, 3, 4, 5, 6, 7, 8. 9, 10. Oh yeah, 10, that's 10. I still don't get it. I don't get this one. Dingus, you're alive. Oh my god. I was so worried. Are you like fucking stupid? You scared the shit out of me, dog. Like, where the fuck were you? I was like so scared, dog. Like, I thought you were like gone. Like, you were always talking about like death and everything. And all of a sudden you went quiet. And you just can't shut the fuck up. And you went quiet. And I was like, yo. I was like so scared, dog. The fuck? I'm not doing this. The fuck? I don't know. I don't know how to do this. What is that? Okay. Am I like audible? Like, no, I deleted YouTube. My attention. That is easy one. Yeah, I know it's easy, but can you like? I just don't get it. I just don't get it. What the fuck happened here? Okay, I got this one, and I got this one, but what the fuck happened here? It should be like. What happened here? Can someone explain? Find total potential energy of M at the center. So it should be like, should I use this formula, right? I should use this formula, and it's going to be like 10 of them. So I should like find 10. So the potential energy between this, and this, this, and 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 this, like this and this. It's making sense, but then what happened here? Like, I don't know. I got it, but yeah, but it's but what? How it's like this 4m squared a by root 2, bro. So infinite at the center of work okay, at the center equals the work done. But how are we getting this? Oh my gosh, dog, come on. You know what? I'm like giving you my telly. You can like literally explain it to me on like a voice. GMM by R is potential energy. Okay, GMMR is potential energy. Okay, GMM by R is my fucking pen. Okay, I have the sketch pen now. Please explain. Here, M is small m. Okay. Okay. Oh yeah. Okay. So it becomes m squared. So it's like gm squared by r, right? And prioritize bio and chemistry physics ain't trustworthy twin. I know. But like, I know. I'm like really focusing on bio though, you know. But like, I just think that maybe I should just try once to like score great in physics. I still don't get it. And the a by root 2. Hold on. No, you lost to me in NCERT battle. Shut up. Chingus, shut up. And I like even texted you on Telegram. Okay, hold on, Mr. Sarthak. Can you like please? Please, you know what? I'm like giving you my telly right here. Can you like please send me a voice note explaining what the fuck actually happened here? Please, just one voice note. No, I need to like move on to the next problem. I'm so sick of this. Fuck it. You know what? Fuck it. But I need my pen. Oh, my stupid pen. I don't have a pen now. Great. Anyways, I'm moving on to this next one because I have like very limited time, and you know how much I have to like cover. Oh, it's insane. Okay, if root 2 is the distance from M to M from the center. Alright, move on. I will send in 5. Okay. Well, I got attacked. The fuck, bro? What do you mean? Okay, you can like send it to me. Thank you so much. GPE of the Earth mass system. Okay, dog, let's go. Who the fuck is it? Let's go here. Chinggis, seriously, not in mood right now, okay? I have a test today. Okay? I just can't. I'm really glad you're alive and not dead. I just needed to make sure that it is okay, everything is okay. But I can't with you right now, okay? Just leave me alone. Del U equals mgh1 plus h by r. Okay, dog, we get it. We get it. mgh upon fuck. So that's like gmmh. What? R squared upon 1 plus h by r. The fuck is that? From surface to height h. The gravitational potential energy. Yeah. Oh, finally we're at the escape velocity pod. Okay, oh my gosh. Kepler's fucking law. Kepler's fucking law. Okay, I'm sorry. I wasn't like seeing the chat. But this. No, thank you. The fuck is wrong with this lamp, dog? Like, I should like shut it off instead. Like, oh my gosh, I look like a fucking ghost. Do y'all like me as a ghost or a zombie? If I were a zombie, would y'all like still be nice to me? The fuck am I even talking about? It's time to get serious. Okay. Huh. So I just need to like keep this formula in mind that it's mgh upon 1 minus h by r, 1 plus h by r, and we good. Okay, and then we have like equals gmh by r squared upon 1 plus h by r. The fuck, yeah. I think I got it. I think I got it. The object of a mass raised to height h equals 2h from the Earth's surface, change in its potential energy, dog. 2r. Uh-oh. Will be. Oh, I see. Oh, I see. Now, finally, escape velocity type shit. Try a luck on the whiteboard lectures for work, power, energy. That shit goated. I don't have that much time, dog. I have a test today. What do you think? I have no time left, dog. I'm like gonna die. I am gonna fucking die. How much portion is left on your bio, 11th or 12th? I think like not much. Yeah, I think like I've done like most of it. Yeah. Anyway, so escape velocity finally, yay! Root 2 gm by r. Ve equals root 2 g r. Ve equals 8 by 3 g rho. If p is constant, it's inversely. Oh. Okay. Okay, yeah. I should probably write these formulas down on this piece of paper. Oh, yeah, of course, this one. And now, the change in potential energy equals mgh upon 1 plus h by r equals gmmr. Oh, h upon r squared 1 plus h by r. Yeah, damn right. Escape fucking velocity. Escape velocity. I will finish in 3 hours if you watch it 2x. It will finish in 3 hours if you watch in 2x. If you do it while skipping. If you do it while skipping into. Bro, wait, hold on. I think you're like. I need you to see my situation here, okay? Let me just. Okay. So, this is my planner. Wow, okay? And I have to like get done with all of these. Yep. And I've done like this and this out of all this till now. I think I'm like good. Boy, I am good. Wow, I am good. Let's like. Let me like screen again. Yeah, that's good, yeah. Just do 12th physics plus bio and chem MBBS. Oh my gosh, thank you for the kind words. But I need to like score something in this test, you know? Okay, I'll keep that in mind. Next verse, let's just get done with these bad fucking niggas. I'm sorry, I didn't say the N word. I'm sorry. I said, oh my gosh, I'm so fucking sorry. Escape velocity. It's not like anyone's gonna watch the stream. Okay. VE equals root 2G M by R. Okay, girl. Equals root 2GR. Okay. Equals root 8 by 3 pi G rho R squared. Well, that's a good one. If mass is constant, V is proportional to R. Well, that's like opposite. Rho is constant, V is proportional to 1 by root R. Great. Now, velocity of an object at infinity when projected at Vg greater than Ve. What is Vg? Okay. And then it's gonna be this one. Okay. Now we have like the fucking Kepler's law left. No, this fucking bullshit is also left. Wow. You're still in a better position. In my case, full-length tests are already going on at Allen. You will do it. Guys, Let's just really hope I make it, okay? Okay, let's go. Hold on, hold on, hold on. Okay. Okay. Orbital velocity. So we've done this one. Okay, we haven't. If we gotta like find if the velocity, okay, v at infinity equals root vg squared minus ve squared. Vg is smaller than h max would be. If Vg is smaller than Ve, H max would be R upon Ve squared upon Vg squared minus 1. Wow! Great. Okay. I'm gonna fucking turn off this light. Turn this light off. Like, it's like not even working, dog. Like, what the? Escape velocity from height h. From height h. Oh, that's a good one. That's oh my gosh. That's a good one. Q&A. Oh my gosh, I have 92 subscribers. Out of no fucking where. Nobody's scoring in full syllabus right now. Bro, full syllabus already? It's not really a full syllabus, dog. Like, it's not full syllabus, but like full 11th. I'm just saying. No, dog, some people are scoring like 600 and 500. I don't know how the fuck they do it. I'm gonna fucking kill myself. V equals negative root 2gm r plus h. I'm gonna. Oh my gosh. So for Earth to become, I am better day by day and I stay hard. Oh. But my score 640, bro. I am better day by day and I stay. What do you mean I stay hard? That was okay. Shut the fuck up, Arisha. You need to get to work. Okay. If okay, that's the escape velocity from height h. For Earth to become a black hole, R should be like 1.48 millimeters. Yo, that's a pretty sick information right there. For Earth to become a black hole, R should be 1.48 fucking meters. Y'all are doing so great, and I'm like, I'm not scoring well. If object is projected with speed vg, then I'm gonna die. Bro, so much. How the fuck am I supposed to keep this in mind? Do bio. That is 360 marks. I have done it. See, hold on. Let me show you bio's syllabus. Hold on. See this. And chem is 180. Okay, fine. I'll focus on them. But like, can you like see this? This is what's coming in like today's test. Yes, the test is today. I think I've like done also I have doubt in Animal Kingdom, this fucking shit. And I think I again forgot biological classification. No matter how much I study it, I'm still gonna forget it. And I think I'm gonna lag in these two. But oh man, I forgot to do biomolecules. Oh man, this chapter is like huge. I mean, I forgot to revise this one. You know what? Fuck it. I'm gonna polish my physics. Physics. If object is projected with speed vg, then like when like it's like final exam time, I think I'm gonna do. Ouch. My ankle is gone. Okay. Vg is greater than Ve, Me plus mechanical energy is positive. It's hyperbolic, and Vg parabolic, and mechanical energy is 0. Do I care if it's greater than this? The fuck is V naught now? What is V naught? You know what? I'm not. Sorry. Fuck it. I'm not doing it. I know it's like very important, but I'm not doing it right now. Orbital velocity. Do question practice to not forget. I know. I'm gonna do that. Don't worry. Just like, let me do the formula. It's like a couple more left, and then we'll just do little PYQs. Energies of satellite. Okay, verify. Orbital velocity. Oh, that's the orbital velocity. Okay, cool. Orbital fucking velocity. Okay, girl. V naught. It's not V naught, it's VO. It equals GMR plus H. Wait, I think I've seen that somewhere. That's like half root. Oh, yeah. VE equals root 2 V. Oh, yeah, that's what I was like saying. I saw it somewhere. A satellite near the surface of Earth. VO is gonna be root GR equals root 4 by 3 pi G rho R squared. Yeah. V satellites increased by root 2% or 41.4%, then it'll escape to infinity. Oh. Okay. Yeah, I think we get that. The radii of the circular orbit of two satellites A and B of Earth are 4R and R respectively if the speed of the satellite is A. Of satellite A is this, and the speed of satellite. Oh my god, I should fucking god. Okay, The radii of the circular orbits of the two satellites A and B of Earth are 4R and R respectively. This chapter is quite easy. Pick hard one. I can't. I need more water. But who's gonna get to me water? I'll be right back. I'll be right back. I'll be right back. See what happened to me here. Ouch. See the bruise? It like hurts. Ow. Don't ask what happened. We are back. I am back. Wow, so we got our light back. I'm like speaking so loudly, everyone is like asleep. It's 3 a.m. and I'm like, I can't like speak. Like, I can't. I just can't speak like in a lower amplitude. Oh my gosh. Like such a so No, I'm not stupid. I'm smart, okay? I'm smart. Okay. Where were we? The radius of the circular orbit of two satellites A and B of the Earth are this and this, respectively. If the speed of satellite A is 3b, then the speed of satellite B will be. We just have to like put it in the formula, right? Huh. Hold on. So we know that orbital velocity equals root gm by r plus h, right? Yeah. So it's gonna be root v o dash would be gm upon 4r plus h. No, oh wait, hold on. I'm like following the wrong formula, I guess. Since when it's like inversely proportional to r, how come it's like inversely proportional to r? How? V is proportional to 1 by root r. So this is what the fuck? You know what? Whatever. Let me just write that down. Is inversely proportional to root r for some reason. But like here it says it's like directly proportional. Then what changed, dog? What changed? Okay, how is this? What? The speed of satellite A is 3b, the speed of satellite B. How come? What formula are we even following? This one or that one? And how are we supposed to know? Listen, Geta only, it will boost your energy. Listen, Geta, what's Geta? What's Geta, bro? I don't know. It will only boost your energy. Geta? The fuck is Geta, though? Anyways, I was saying, how? You know what? Let me ask Gemini. Only Gemini can fucking help me with this one. Yeah, that's right for sure. Gemini, save me, please, dog. Fucking. Okay. I don't know if y'all can like see it, but y'all can't. Okay, dog. Like, how the fuck? It's like, okay, like there are like literally two formulas. It should be like directly proportional to root r, not inversely. Okay, wait. You're saying v equals under root gmr. That's the reason. Which speed are we even talking about? In general case, when like, oh, that's like over on like Earth's surface. It's this. Okay, but like in general case, okay, cool, I got it. Any speed can be calculated by that formula. Any speed. Okay, fine. Energies of satellite. We got like 1,000 formulas for speeds, I guess. The general formula is gm upon r. Root gm by r, okay. Root gm by r, Fine. Energies of satellite. Yeah, just remember their ratio. Like, this is important. There's also like a P by Q on it. Finally, yeah. Oh my gosh, these questions. These. Your stream ain't what? It is. Don't lie. It is visible. You need to like refresh your page because it's like visible to me. I like also opened. What the? What? Okay, we're finally at this point. Okay, let's go. Oh my gosh, don't say that. Okay, we're finally here. Let's just write down the energy of satellite. U equals watch a 5-minute video of whatever you are stuck. Oh my gosh, so you like sent me a message. Okay. That's a cat in a Gojo outfit. Okay. Okay. You know what? Let me like unmute you. Now I'm like gonna get notified when you like say something. Anyways, yeah. U equals negative GM R plus H dog. K equals GMM 2R plus H. So like that's like half of it. T equals negative. Oh, that's also like positive. Negative GMM 2R plus H. So these are like okay. What's binding energy? It's like positive half, right? It's like positive half. It's literally same as the kinetic energy, right? Can you hear that? It's my stomach. It's making noises because I'm hungry as fuck. Let salty. Okay, I can like see everyone like laugh. Binding energy of a particle, Be equals G. Binding energy is the energy required to escape the orbit. Really? Oh, thanks for telling me. Binding energy of a body is twice the binding energy of a satellite. Okay. BE of a body is twice the BE of a satellite. Like, who is making these rules? I'm like so hungry, dog. If you can like hear my stomach growling, please ignore. Cause I'm really hungry. I don't think I'm gonna like retain all this information. I'll be able to retain all this information. Finally, Kepler's law. It's almost 3 a.m. That's why it is equal to KE because just slightly more energy than that and satellite will split out of the orbit. Okay, but what? Hmm. Time period, let's go. Satellite. Time period of satellite. F is proportional to gamma raised to power. What the Just give me the formula. 2 pi. The fuck is gamma? The fuck is gamma here? Wow, that is 2 pi root r e plus h whole raised to cube upon GME. Wow. You know what I need to like keep in mind that this thing that like t squared is proportional to gamma cube and t is equals to root k gamma 3 by 2. And k equals 4 pi squared gm. Okay. What kind of questions can be formed? I know what kind. T squared is like proportional to Kepler's law. I'm gonna watch a video on this one. Kepler's fucking laws. Bro, this. No. Let's just watch a video on Kepler's. Did you hear that? That's how stiff I was. Let's watch a video on Kepler's law. Let's go. Kepler's law. The book. Wow, 1 hour. Great. Yo. What in the world, in the goddamn freaking universe, what in the name of Kepler's is this? Wow. Wow. This is wild. Whoa, this girl is on fire, dog. Like, that is crazy. That is crazy. I think this guy will do justice.
केपलर्स लॉस, केपलर ने हमें 3 लॉज दिए थे जोनास केपलर ने, और तीनों लॉज ऑब्जर्वेशन बेस्ड है। टाइको ब्राहो ने कुछ बहुत सारी ऑब्जर्वेशन करी थी, उनके बाद उनकी ऑब्जर्वेशन को पढ़ा जोनास केपलर ने, उन्होंने कुछ लॉज दिए जिनका कोई प्रूफ नहीं है, ऑब्जर्वेशन बेस्ड है। फर्स्ट लॉ ऑफ ऑर्बिट्स, उन्होंने बताया, पहली बार ऐसा बताया किसी ने कि प्लैनेट्स मूव अराउंड द सन इन इलिप्टिकल ऑर्बिट हैविंग द सन एट वन ऑफ द फोकाई। तो पहले ये मानते थे सबकी, पहले तो अर्थ को सेंटर मानते थे, फिर उसके बाद ऐसा वो जियोसेंट्रिक मॉडल था, अभी हीलियोसेंट्रिक है, यहाँ पे सन सेंटर में है लेकिन सर्कुलर ऑब्जेक्ट ऑर्बिट नहीं है, इलिप्टिकल ऑर्बिट है, ये हमें केपलर ने बताया। तो उसके लिए भी देखो हमारे पास इस तरीके से अगर इलिप्स होता है तो इलिप्स के 2 फोकाई होते हैं। अब सन इनमें से किसी भी एक पे हो सकता है। लेट्स से यहाँ पर हमारे पास सन है m, और यहाँ पर हमारे पास ये स्मॉल m है जो इस तरीके से, इसकी कुछ वेलोसिटी होगी, यहाँ पर ये इस तरीके से मोशन कर रहा है। तो हमारे पास यहाँ पर इलिप्टिकल ऑर्बिट होते हैं और 2 फोकाई होते हैं, दोनों में किसी भी जगह पे सन हो सकता है। अच्छा, यहाँ पे कुछ पॉइंट्स होते हैं, मैं आपको फिर से बता देता हूँ। जो पास वाला सबसे नियरेस्ट पॉइंट होता है उसको हम बोलते हैं पेरिजी, और जो सबसे दूर वाला पॉइंट होता है वो होता है एपोजी। ये 2 वर्ड्स हैं जो आपको याद होने चाहिए। आगे देखते हैं नेक्स्ट केपलर्स लॉ क्या है। सेकेंड लॉ, द लॉ ऑफ इक्वल एरिया।
The first law.
Next.
Binge watch this guy's 33 years PYQ series. He has marked all important formulas and questions. Binge watch what? Hello, do you attend a live class of binge watch what? Like him?
Second law, the law of equal area.
We're talking about him. Mm-hmm. Okay, guys, I know. I'm sorry. There's some network issue. Where were we? Where the fuck were we? Right here. Your link is not functional. Not functional.
यहाँ पे पहले तो बताओ सन कहाँ है? सन यहाँ सेंटर में नहीं होगा, सन होता है किसी एक फोकाई पे। ऑलराइट, यहाँ पर जो हमारे पास ऑर्बिट करने वाला सैटेलाइट है वो लेट्स से यहाँ पर था कभी,
Just give me
फिर
the
उसके बाद थोड़ी
fucking
देर बाद वो
formulas.
यहाँ पर आता है। तो पहली बात तो इसमें एक और चीज लिखी है, दिस लॉ इज अ कॉन्सिक्वेंस ऑफ कंजर्वेशन ऑफ एंगुलर
Do you
मोमेंटम ऑफ
attend
प्लैनेट
the
अबाउट
live
द सन।
class of
इसका एंगुलर
PW?
मोमेंटम अगर आप देखो, यहाँ से इसका एंगुलर मोमेंटम कंजर्व
I
करा
don't
पा रहे हैं।
know.
क्यों करा पा रहे हैं अबाउट सन? क्योंकि इस पे जो भी फोर्स लग रहा है, कौन सा फोर्स लग रहा है? ग्रेविटेशनल फोर्स। ग्रेविटेशनल फोर्स इसी पॉइंट से जा रहा है, तो यानी कि ग्रेविटेशनल फोर्स के कारण कोई टॉर्क नहीं है इसके ऊपर, है ना। अगर मैं सन के अबाउट बात करूँ,
No.
टॉर्क नहीं है तो हम एंगुलर मोमेंटम को कंजर्व करा पाएंगे। तो मैं क्या लिख सकता हूँ, दिस इज पॉइंट नंबर 1, दिस इज पॉइंट नंबर 2। मैं लिख दूंगा L1 इज इक्वल टू L2। क्यों? क्योंकि टॉर्क ड्यू
Okay. Why my screen is like... Y'all can't see my screen, dog. Like, why is like blank? The fuck? Okay, now y'all can see, right? Now y'all can see. I said no, I do not attend the live classes of PW.
ग्रेविटी इज इक्वल टू 0, है ना। L1 की वैल्यू क्या है? यहाँ पर हमारे पास कुछ डिस्टेंस है, लेट्स से दिस डिस्टेंस।
How can someone... How can you like... How can you keep sending non-functioning links? Just name the series and teacher. I'll follow. It just search 33 years physics PYQ NEET. Okay, like the whole physics, like are we doing a chapter or like the whole physics? You can't hear me. Like chapter wise. Oh, okay. Cool. I'll check it out. But I don't think I like have time left. Oh my gosh. I don't think I have like time left. So I'll just... Yeah, it has marked all the formulas. Like who is the teacher? Who? Is it like MR, sir? This guy only Kirar something. Oh my god. Okay, I'll see.
This was R1। सिमिलरली यहाँ पे हमारे पास R2 डिस्टेंस इस तरीके से, यहाँ पर वेलोसिटी है v1, यहाँ पे वेलोसिटी है v2। L1 की वैल्यू हो जाएगी, m v
think. Let me see questions on Kepler's law. Kepler's law. P by Q. Yeah, this shit will be good. I think this will do.
इसको हम लॉ ऑफ क्या है पहले वो आपको बता देता हूँ ताकि ये आपको लॉ समझ में आ जाए। इलिप्स का मतलब क्या है? तो ऐसे ये जो पिचका वाला सर्कल सेंसेस है उनका सम अगर कांस्टेंट है चाहे वो कहीं भी रहे, अगर इन दोनों फोकस से उस पार्टिकल की डिस्टेंस का सम कांस्टेंट है तो वो जिस पाथ के ऊपर मूव करेगा उस पाथ को हम क्या बोलते हैं? इलिप्स बोलते हैं। फॉर एग्जांपल अगर पार्टिकल यहाँ पे है, ठीक है, तो यहाँ पे ये वाली डिस्टेंस r1 हो जाएगी, ये वाली डिस्टेंस r2, तो अभी भी ये सम उतना ही आ रहा होगा जितना पहले आ रहा था। वो क्या यहाँ पे पहुंच जाए, यहाँ पे पहुंच जाएगी तो ये वाली डिस्टेंस कितनी r1 और इस दूसरे वाले फोकस से ये वाली डिस्टेंस होगी r2, इन दोनों का सम अभी भी उतना ही आएगा। मतलब
Shit, this time it's done. Kepler's law. Yeah. Think I'm gonna. This one. Genghis, I'm telling you, it's not time. It's not time. I really can't talk to you right now. Okay. A planet. The furthest away at the distance R2 will be. Of course, that will be according to the law of conservation of angular momentum. Wow. Okay. Okay. Time taken by CD will be greater than T1. Twice. Oh, and then it's gonna be 3 is B. Of course. Yapin and Yapin. The period of revolution of planet A around Sun is like 8 times that of B. The distance of A from Sun is how many times greater than that of B from the Sun? Oh my gosh. I feel sleepy. The effect of caffeine is wearing off. It's only 3 a.m. Oh my gosh. The ratio of time period of the planet is T squared is like proportional to a's cube, right? We're gonna apply that formula, and hell yeah, and that's what I'm talking about. The distance of the two planets from the sun are 10 to the power 13 meters and like 10 to the power 12 meters respectively. The ratio of the time period of planets is I don't know. やめてください please. I don't. わかられ Distance of the two planets from the sun. Oh, come on. Easy. It's the same thing. Yeah. See, it's literally the same thing. Okay, no problem there. If the planet is moving in elliptical orbit, TBR respectively for kinetic energy, gravitational potential, energy, total energy, and magnitude of the angular momentum. Somebody Daddy killed. It's never ending chapter. I'm like so done. The largest short distance of the because the momentum L is conserved. Yeah. Fine. You know what? Now shut the fuck up. I'm done with gravitation. Now let's do fluid. You know what? Let's do motion. Let's do laws of motion by Adoniti into fucking fuck. Let's just do it. Oh yeah. And no, wait, no. Oh my gosh, no. Be safe, y'all are like jewels, literal jewels. Okay, now let's do laws of motion, and I know what kind of questions come from here. And I'm telling the truth. Hold on, 19 videos. Oh no. No, 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 no. Today I have another full test and one last chapter revised, then boom, boom, this time rank 1 will go. I'm like so happy for you, but I'm also like kind of jealous. Yeah, very jealous of you. I wish I could. Oh my gosh, you can't see the teacher. Share this. Yeah, now y'all can like see. I'm sorry if I'm like too fucking bright. Yeah, that's better, I guess. Or I should like turn it away. That's okay. Wait, normal tension fiction. This video is like 50 minutes. Wow. I don't think we even have that much time. Okay. Along the string away from the body. Maybe like get to the formulas. No way, literally need 2026 and 3B is aura farming in my chat. Okay, hold on. So we have like a theta 1, I mean theta 2, T1, T even sine theta, T even cos theta. And then we have like this thing. In the upward direction, we have these many forces, and okay. Lami's theorem, I love it. You know what? I'm gonna write this down. I bet you're like gifted. You're like super smart already. You don't even need Alan or anything. That's bullshit. You don't need anything. You're just perfect. Born genius. It's just people like me who have to. You're so lucky. Not gonna lie. Okay, first let's like write Lami's theorem. Okay, so this, and this, and this. We have like these three things doing their things. This is theta 3. This is 9t plus theta 1. This is 9t plus theta 2. Where the fuck is theta? T1. What? That wasn't Lami's theorem. That's not what I remember. No, that's. Wait, hold on. I don't think this was Lami's theorem. Lami's theorem. Yeah. Yeah, this was it. This was the theorem. Yep, this was the theorem. See, like, hold on. This was the theorem, dog. So if it's like alpha, gamma, and beta, and that's F1, that's F2, and F3, then F1 by sine alpha equals F2 by sine beta equals F3 by sine gamma. Damn right. That's what I'm talking about. Where were we? Here. Oh, it's like relative to this case. Okay. Ooh, ooh. Wow, is some like high level shit. It's like so clever. Now that's what I'm talking about, my boy. Hmm. Pulley. I'm like so hungry right now. I can't even tell. This is a massless pulley. Literally, I'm so hungry. Let's draw our pulley system. So excited. So this is our pulley, 2T upwards, and T1. No, like it's gonna be the same, right? T downwards. I mean, there's block 1 and there's block 2. M1G, M2G, A up, A down. And let's see what we got here. Now, force equals MA, M2G minus T, M2G minus T. Oh, of course. So it's like gonna be what? M2A. How? M2A. What? That is not the equation. Oh, yeah, that is. And M1G minus plus up minus. No, we're talking about M1, right? M. Okay, T, which is bigger? T is bigger. T minus M1G equals M1A. T equals 2M1 M2G upon M1 plus M2. I know this one. And we can find A equals M2 minus M1 upon M plus M1 plus M2 times G. That was easy. M1 minus M2 minus M1 upon sum the. Yeah, thanks. Tension is here. Tension is here. And then MG, M2G, is M1G, but it's like downwards. And here it's gonna like, I think that's gonna be like friction. That's normal. So yeah. So if this is the acceleration, then M2G minus T equals M2A and T equals M1A. Great. And N equals M1G. Yeah. Okay. No friction. Whoa, this system is sick. Mm, the fuck is going on? Can't be like serious. This can't come in neat. My network is dying. Yeah, I was saying like this can't come in neat. Like y'all gotta be like seriously kidding me right now. This can't. 6 plus. Like 4. It's gonna be 10. Mhm, mhm. The Oh, these kind of questions. And 1.852 and 1 minus. Okay, guys, are we like gonna do bank pseudophores, numerical and pseudophores? These are like the banged road kind of stuff, right? I really hope so. Okay, let me just like see. No, it's not. Two block system, friction. Wow. and mine is mg. And Okay, so my song is over and it's time to get back. By the way, we have like 3 hours left. So I don't know. Let's just eat something first because we also need to like stay alive, don't we? The fuck? Why do I look like a fucking 12-year-old? Did you ever watch any lecture of Salim, sir? I can't watch lectures yet. You know what? I'm gonna try him in my for my next test. I'll be having some chapters of 12 that I haven't like touched yet. So I'm like doing like following him because I've like already done these chapters and I just need revision. But you know, like MR sir, he's like also very great and I like trust him so bad. But like I don't know, Salim sir, I like never tried him, so I'm a little skeptical about it. But if you're like really pushing me, and maybe I'll just try him for a chapter and I'll just let you know. But let me first fuel myself up. Wow, it's like really cold. Hmm. Why the fuck is like lagging so much? Like I'm doing this. Okay. Where were we? Here.
These have same acceleration. कहने का मतलब है कि यहाँ पे आपके सामने एक वेज है जिसका मास m2 है और इसके ऊपर एक ब्लॉक है जिसका मास m1 है, ठीक है। इस वेज पे राइट साइड आपने F1 फोर्स लगाया जिस कारण से दोनों साथ साथ ट्रैवल कर रहे हैं विद एक्सेलरेशन a1, ठीक है। M1 डज नॉट स्लिप, येलो वाली ब्लॉक वेज पे स्लिप नहीं कर रही है। अगर ऐसा है, अगर ये दोनों एक साथ सेम एक्सेलरेशन से मूव कर रहे हैं तो हम इन दोनों को एज अ सिंगल एंटिटी ट्रीट कर सकते हैं, एज अ सिस्टम ट्रीट कर सकते हैं और हम कह सकते हैं दैट इज F1 इज इक्वल टू मास इनटू एक्सेलरेशन, यानी कि F1 इज इक्वल टू m1 प्लस m2 मल्टीप्लाइड बाय एक्सेलरेशन, यानी कि एक्सेलरेशन इज F अपॉन टोटल मास। लेकिन अगर ये येलो ब्लॉक आपको स्लिप कर रहा होता, आप यहाँ पे कोई और ही फोर्स F2 लगा रहे हो जिस कारण से ऐसा देखा गया कि ये m1 जो है इस वेज पे अलोंग द इंक्लाइन स्लिप कर रहा है विद सम एक्सेलरेशन a1। दिस एक्सेलरेशन इज विद रिस्पेक्ट टू द वेज, ठीक है। वेज के ऊपर इस एक्सेलरेशन से वो नीचे गिर रहा है और ये वेज जो है वो आपको राइट साइड a2 से मूव कर रहा है। अब क्योंकि यहाँ पे दोनों का एक्सेलरेशन सेम नहीं है, दोनों साथ साथ मूव नहीं कर रहे हैं, तो आप दोनों को एज अ सिस्टम ट्रीट नहीं कर सकते, आपको दोनों बॉडीज को सेपरेटली ड्रॉ करना पड़ेगा, ठीक है। टेक m1 एंड m2 एज सिस्टम, अ बिग क्रॉस, यू कैन नॉट डू दैट, क्लियर है। अच्छा, अब ये जो यहाँ पे आप वैरायटी देख रहे हो ये बेसिकली एक क्वेश्चन भी है, तो लगे हाँ तो चलिए हम इसको भी एक बार डिस्कस कर लेते हैं। तो यहाँ पे हमसे क्या कहा जाता है, हमसे पूछा जाता है कि इस a1 की एग्जैक्ट वैल्यू क्या है। तो आप यहाँ पे देख सकते हैं वी हैव ड्रॉन द फ्री बॉडी डायग्राम ऑफ दिस येलो ब्लॉक सेपरेटली। हमने क्या किया है, इस ब्लॉक को तो पहली बात एक पॉइंट मास की तरह यहाँ पे बनाया है, इस पे आपको नॉर्मल लग रहा होगा इस तरीके से और डाउनवर्ड डायरेक्शन पे इसका वेट लग रहा होगा mg।
Okay, I mean, everything is fine, but why is he like fisting this poor blue dino? Like, I think that's assault. You know what? I think this series is like actually gonna work for me. Like, thank you, whoever told me about this series. And like, I really appreciate if we just would stop fisting this poor little dino. Like, I can't stand it, but guess we'll have to. I told you what you didn't. You didn't tell me. Second thing, I think I'm gonna take a nap, bro. Like, I've been up for like so long. I think I deserve a little nappy. Just like 10 minutes or like 5 minutes. Then I'll be back, and I still have like some time left. We'll see what happens in the test. What? Study was your break from sleeping, bro. You slept 12 hours? You studied for 4 hours. I'm going. Oh my god. What the fuck is wrong with you? Okay, not 5. Just make it 10, please. Just make it 10, okay? Please. Okay, what the hell? Chingus, what the hell? Oh my god. Why would you think I'm blushing, bro? I was just laughing at someone's stupidity. Anyways, we're back. Oh my gosh, I have a test today. It's 4:45. Look, time flies so fast. Why the fuck am I like looking so bright? Like, tube like. Please say something in Hindi. Do you have like a kick or something? I don't tell. I mean, I don't do what others tell me to do. Oh no, come on. Okay, finally we're back. Finally we're back. Okay. So we were here.
The height of each liquid is h. ये वाली height दोनों में h दे रखी है h. A solid cylinder of length L and density D is put in this container. इसमें एक cylinder डाल दिया हमने. The cylinder floats with its axis vertical and length PL P की value 1 से छोटी है. Density D yes sir. Of densities rho and n rho यहाँ पे n की value ज़्यादा है. R put in a container. तो अच्छा एक कंटेनर में दो लिक्विड डाल दी जिसकी डेंसिटी rho और n rho है. n की value 1 ज़्यादा तो कौन सा वाला लिक्विड नीचे जाएगा? इसकी डेंसिटी rho, इसकी डेंसिटी n times rho. इस वाली केस सिर्फ rho. The height
Okay, my network is like not very stable. I think it is now. Sorry from issue from my side. Who the fuck is this Adia? Adia, the fuck, like, bro, like, this is a place to study. Like,
of each liquid is h. ये वाली height दोनों में h दे रखी है h है. A solid cylinder of length L and density D is put in this container. इसमें एक cylinder डाल दिया हमने. The cylinder floats with its axis vertical and length PL P की value 1 से छोटी है. In the denser liquid, the density D is equal to. तो हमारे पास यहाँ पर एक इस तरीके से cylinder है जिसका axis vertical ऐसे वो तैरता है. ठीक है. उसकी length है capital L. L में से कितना वाला part P times L नीचे की तरफ तैरता है. ऊपर कितना तैरा होगा वो जाएगी value 1 minus P times L या फिर L minus LP. ओके. इसका कुछ क्रॉस सेक्शन ले लिया होगा उसको मैं मान लेता हूँ. इस वीडियो को पॉज करो, सॉल्व करने की कोशिश करो. इस पे बॉइंट फोर्स हमें बैलेंस कराना है mg के बराबर और हमारा आंसर आ जाएगा. नहीं करना तो मैं सॉल्व कर दूंगा. देखो बॉइंट फोर्स इज इक्वल टू mg हमें निकालना है। बॉन्ड फोर्स कितना लगा होगा? देखो बॉन्ड फोर्स लगा हुआ नीचे वाले कारण कुछ ऊपर वाले कारण। पहले नीचे वाले कारण देखो, बॉन्ड फोर्स की वैल्यू होती है रो जी रो वी जी, ठीक है। डेंसिटी नीचे वाले की है n इंटू वॉल्यूम कितना डिस्प्लेस हुआ है इसका कुछ क्रॉस सेक्शनल एरिया इंटू ये वाली लेंथ, एरिया की वैल्यू कितनी थी a इंटू p इंटू l, है ना, ये हमारी वॉल्यूम आ गई रो v इंटू g प्लस ऊपर वाले लिक्विड के कारण भी कुछ एरिया में बॉन्ड फोर्स होगा, तो उसके लिए हम ऊपर वाले लिक्विड की डेंसिटी लगाएंगे, तो वो डेंसिटी कितनी हो जाती है रो इंटू वॉल्यूम कितना है यहाँ पर, इसका वॉल्यूम है क्रॉस सेक्शनल एरिया इंटू ये वाली लेंथ, क्रॉस सेक्शनल एरिया a इंटू लेंथ की वैल्यू कितनी है 1 माइनस p टाइम्स l इज इक्वल टू इस पूरी सिलेंडर पे नीचे की तरफ ग्रेविटेशनल फोर्स कितना लगा होगा, तो ग्रेविटेशनल फोर्स हो जाएगा मास इंटू g, मास की वैल्यू कितनी जाएगी डेंसिटी इंटू वॉल्यूम इंटू g। अब डेंसिटी इस सिलेंडर की डेंसिटी की वैल्यू हमें क्या दी हुई है, वो वाली वैल्यू हमें दी हुई है d इंटू इसका वॉल्यूम कितना है क्रॉस सेक्शनल एरिया इंटू टोटल लेंथ l इंटू g। हमारे पास इक्वेशन आ गई बॉन्ड फोर्स इज इक्वल टू ग्रेविटेशनल फोर्स। देखो कितनी चीजें यहाँ पर कैंसिल आउट हो जाएगी, g सभी जगह कैंसिल हो जाएगा। अच्छा यहाँ पर हमने g लिखा है, इसमें जी लिखना पड़ेगा ना रो।
The fuck am I supposed to understand from this? Like, really? What was that? Did anyone get anything? Of course not. I'll just have to rewind. Like, the fuck is going on here?
लिक्विड सी अच्छा सवाल है, इसको सॉल्व करना चाहिए खुद से पॉज करके। ऑफ डेंसिटीज रो एंड n रो, यहाँ पे n की वैल्यू ज्यादा है, r प्रोटीन कंटेनर, तो अच्छा एक कंटेनर में दो लिक्विड डालें जिसकी डेंसिटी रो और n रो है, n की वैल्यू ज्यादा है तो कौन सा वाला लिक्विड नीचे जाएगा, इसकी डेंसिटी ज्यादा होगी, n रो की डेंसिटी रो से ज्यादा है, तो हमारे पास एक ऐसे कंटेनर है। ओके यहाँ पर हमारे पास दो लिक्विड है ऐसे, ये वाला है n रो, इसकी डेंसिटी n टाइम्स रो, इस वाली है सिर्फ रो। द हाइट ऑफ ईच लिक्विड इज h, तो ये वाली हाइट दोनों में h दे रखी है, h है। A solid cylinder of length L and density D is put in this container. इसमें एक सिलेंडर आ गया हमने। The cylinder floats with its axis vertical and length PL, P की वैल्यू 1 से छोटी है, in the denser liquid. The density D is equal to, तो हमारे पास यहाँ पर एक इस तरीके से सिलेंडर है जिसका एक्सिस वर्टिकल ऐसे वो तैरता है, ठीक है। उसकी लेंथ है कैपिटल L, L में से कितना वाला पार्ट P टाइम्स L नीचे की तरफ तैरता है, ऊपर कितना तैरा होगा वो हो जाएगी वैल्यू 1 माइनस P टाइम्स L या फिर L माइनस LP। ओके इसका कुछ क्रॉस सेक्शन एरिया होगा, उसको मैं मान लेता हूँ। इस वीडियो को पॉज करो, सॉल्व करने की कोशिश करो, इस पे बॉइंग फोर्स हमें बैलेंस कराना है mg के बराबर और हमारा आंसर आ जाएगा। नहीं करना नहीं सॉल्व करूँगा। देखो बॉइंग फोर्स इज इक्वल टू mg हमें निकालना है। बॉइंग फोर्स कितना लगा होगा, देखो बॉन्ड फोर्स लगा हुआ नीचे वाले कारण कुछ ऊपर वाले कारण, तो पहले नीचे वाले कारण देखते हैं। बॉन्ड फोर्स की वैल्यू होती है रो जी रो वी जी, ठीक है। डेंसिटी नीचे वाले की है n इंटू वॉल्यूम कितना डिस्प्लेस हुआ है इसका कुछ क्रॉस सेक्शनल एरिया इंटू ये वाली लेंथ, एरिया की वैल्यू कितनी थी a इंटू p इंटू l, है ना, ये हमारी वॉल्यूम आ गई रो v इंटू g प्लस ऊपर वाले लिक्विड के कारण भी कुछ एरिया में बॉन्ड फोर्स होगा, तो उसके लिए हम ऊपर वाले लिक्विड की डेंसिटी लगाएंगे, तो वो डेंसिटी कितनी हो जाती है सिर्फ रो इंटू वॉल्यूम कितना है यहाँ पर, इसका वॉल्यूम है क्रॉस सेक्शनल एरिया इंटू ये वाली लेंथ, क्रॉस सेक्शनल एरिया a इंटू लेंथ की वैल्यू कितनी है 1 माइनस p टाइम्स l इज इक्वल टू इस पूरी सिलेंडर पे नीचे की तरफ ग्रेविटेशनल फोर्स कितना लगा होगा, तो ग्रेविटेशनल फोर्स हो जाएगा मास इंटू जी, मास की वैल्यू कितनी जाएगी डेंसिटी इंटू वॉल्यूम इंटू जी। अब डेंसिटी इस सिलेंडर की डेंसिटी की वैल्यू हमें क्या दी हुई है, वो वाली वैल्यू हमें दी हुई है d इंटू इसका वॉल्यूम कितना है क्रॉस सेक्शनल एरिया इंटू टोटल लेंथ l इंटू जी। हमारे पास इक्वेशन आ गई बॉइंड फोर्स इज इक्वल टू ग्रेविटेशनल फोर्स। देखो कितनी चीजें यहाँ पर कैंसिल आउट हो जाएगी, जी सभी जगह कैंसिल हो जाएगा। अच्छा यहाँ पर हमने जी लिखा है, इसमें जी लिखना पड़ेगा ना, रो इंटू वी इंटू जी करना था, जी से सारे जी कैंसिल हो गए। क्या हमें दिख रहा है कि ए से ए कैंसिल हो जाता है और एल से एल भी कैंसिल हो जाता है, तो बचता क्या है हमारे पास, सिंपल सा बचता है डी एन रो पी। यहाँ से देखो एन आ गया, रो आ गया, पी आ गया, और इसमें से क्या बचेगा, रो बचा है और 1 माइनस पी बचा है प्लस 1 माइनस पी टाइम्स रो। तो इनमें से कोई ऑप्शन हमें दिखाएगा। अच्छा इन ऑप्शन में हम सब देखते हैं कि डेंसिटी रो को इन्हें बाहर कॉमन निकाल लेते हैं, यहाँ पे हम भी डेंसिटी को बाहर कॉमन निकाल लेते हैं, अंदर बचता है हमारे पास एनपी प्लस 1 माइनस पी, तो ये आ जाता है डेंसिटी इंटू 1 प्लस एन माइनस 1 टाइम्स पी। क्या ये हमें कोई ऑप्शन दिख रहा है 1 माइनस, ये हमारा ऑप्शन नंबर डी आ जाता है। इस तरीके से हम इस क्वेश्चन को सॉल्व कर सकते हैं, बहुत ही आसान आसान तो था, थोड़ा लंबा है पर आसान। तो ये क्वेश्चन अच्छा क्वेश्चन, अगले सवाल पे चलें। The approximate depth of an ocean is इतना, ठीक है।
I
The
did not
compressibility of
get
water is
anything from that question. Not a single thing. Nothing. I didn't get anything from that. Wait. How much time do I have left? Let me see. The fuck? I don't have any time left, y'all. I don't have any time left. I'm actually 1 day late. 1 day late. Excuse the broken ass screen. But yeah. I'm 1 day late. Just one more day and please not today. I have a test today. I can deal with it tomorrow maybe. Not today. imagine I'm like given the exam and like in middle of the paper, it like bleeds all over me. That would be crazy.
इतनी, ये हमारे पिछले चैप्टर का सवाल आ गया, बल्क मॉडल का सवाल, एंड डेंसिटी ऑफ वाटर इज इतनी, what fractional compression of water will be obtained at the bottom of the ocean? देखो हमें compressibility दी हुई है ना, compressibility is 45.4 into 10 raised to power minus 11 per pascal, वो क्या होता है हमारा 1 by PO। अच्छा बल्क मॉडुलस की वैल्यू क्या होती है? बल्क मॉडुलस होता है हमारा P excess, है ना, डिवाइडेड बाय माइनस डेल्टा वी बाय वी। हमसे पूछा क्या है, व्हाट फ्रैक्शनल कंप्रेशन ऑफ वाटर विल बी ऑब्टेन्ड एट द बॉटम, फ्रैक्शनल कंप्रेशन ऑफ वाटर यानी वाटर की वॉल्यूम कितनी कम हो जाएगी, हमसे एक्चुअली डेल्टा वी बाय वी ही पूछा है, डेल्टा वी बाय वी। अगर मैं सिर्फ मैग्नीट्यूड की बात करूं तो P excess डिवाइडेड बाय B हमें आ जाएगा, यानी P excess की वैल्यू, एक्सेस प्रेशर नीचे कितना है, रो जी एच, तो रो की वैल्यू कितनी है 10 रेज़ टू पावर 3 इनटू जी की वैल्यू है 10, हाइट कितनी है मतलब डेप्थ ओशन की है 2700 मीटर, सारी चीजें ऐसे में चल रही हैं, इनटू B 1 बाय B है, यानी कि उसको हम K बोल सकते हैं, यहाँ से तो उसको मल्टीप्लाई करेंगे इनटू 45.4 इनटू 10 रेज़ टू पावर माइनस 11, बस हमें 11 इनटू 45.4 इनटू 10 रेज़ टू पावर 3 4 5 6 11 माइनस 5, तो आप सॉल्व करोगे ना तो इसका आंसर आया था अपना लगभग 1.2 इनटू 10 रेज़ टू पावर माइनस 2, और हमारा वही है आंसर, यहाँ पर बी हमारा आंसर आता है। इस तरीके से क्वेश्चन को सॉल्व करें। अगले सवाल पे चलते हैं। इन राइजिंग फ्रॉम द बॉटम ऑफ द लेक टू द टॉप, टेम्परेचर ऑफ एन एयर बबल रिमेन्स अनचेंज्ड, थर्मोडायनामिक्स आ गया नहीं, अभी तक नहीं है, बट इट्स डायमीटर गेट्स डबल इफ h इज द बैरोमेट्रिक हाइट, है ना, ठीक है, एट द सरफेस ऑफ द लेक द डेप्थ ऑफ द लेक, बहुत अच्छा सवाल है, वीडियो को पास करें, क्वेश्चन को सॉल्व करने की कोशिश करो। मैं बता देता हूं इसमें क्या है, हमारे पास इक्वेशन होती है PV इज इक्वल टू nRT, टेम्परेचर कांस्टेंट यानी P1 V1 इज इक्वल टू P2 V2, हमारी वॉल्यूम देखो लेक में क्या होता है, यहाँ पर हमारे पास इस तरीके से लेक है, नीचे हमारे पास डेप्थ में बबल छोटा था, यहाँ तक आ जाता है, बबल का डायमीटर डबल हो गया, क्या हो गया, डायमीटर गेट्स डबल, डायमीटर डबल हो गया यानी रेडियस डबल हो गया, तो यहाँ पर अगर कुछ वॉल्यूम था तो ऊपर वॉल्यूम बढ़ गया, कितना 8 टाइम्स हो जाएगा, क्योंकि वॉल्यूम इज प्रोपोर्शनल टू r क्यूब, तो इस पॉइंट को मैं दे देता हूं नाम 1, इस पॉइंट को दे देता हूं नाम नंबर 2, तो हमारे पास V2 की वैल्यू आ जाती है V2 इज इक्वल टू 8 टाइम्स V1, यानी कि P1 V1 अपॉन P2, अब इससे ज्यादा मैं बता, वीडियो पॉज करो, सॉल्व करके बताओ। ओके देखो हमारे पास आ जाता है P1 V1 इज इक्वल टू P2 V2, अच्छा इन दोनों में बता कौन सा प्रेशर ज्यादा होगा, P1 की वैल्यू ज्यादा होगी क्योंकि नीचे डेप्थ है तो P1 की वैल्यू आ जाती है P2 into V2 by V1, V2 by V1 की वैल्यू है 8 इज इक्वल टू 8 टाइम्स P2। अब देखो हमारे पास आ गया P1 8 गुना है इस प्रेशर का, यहाँ पे जो प्रेशर है इस प्रेशर का 8 गुना, लेकिन प्रेशर बड़ा क्यों होगा, क्योंकि हम कुछ नीचे आए हैं, तो रो वाटर इनटू जी इनटू एच, उसके कारण हमारा प्रेशर बढ़ गया होगा, तो प्रेशर कितना बढ़ गया होगा, ऊपर कितना था हम देखो देख लेते हैं, हमारे पास जाता है डेल्टा P इज इक्वल टू रो इनटू, हमारे पास यहाँ पर एक डेप्थ D से मान, रो वाटर की होगी यहाँ पे, रो वाटर इनटू डेप्थ D इनटू रो जी एच, है ना, ये हमारे पास प्रेशर, यहाँ पर प्रेशर था P1, यहाँ पर प्रेशर है 8 टाइम्स P1, तो डिफरेंस कितना हो गया प्रेशर का, हो जाता है 8 P1 माइनस P1 इज इक्वल टू 7 टाइम्स P1। अच्छा P1 की वैल्यू कितनी है, हमें दे रखा है यहाँ पर P1 इज रिलेटिव डेंसिटी मर्करी की रो है ना, इज इक्वल टू 7 टाइम्स P1 की वैल्यू हो जाती है रो ऑफ मर्करी, तो वो रो इनटू डेंसिटी ऑफ वाटर, ये हमारे पास डेंसिटी ऑफ मर्करी आ गई, क्यों, क्योंकि डेंसिटी ऑफ वाटर से रिलेटिव डेंसिटी को मल्टीप्लाई करोगे तभी तो हमारे पास मर्करी की एक्चुअल डेंसिटी आ जाएगी, ये भी मैंने गलत नंबर दिया इसलिए कुछ ABCD कुछ करके ये रिलेटिव डेंसिटी को भी रोल किया, डेंसिटी भी रो इनटू जी इनटू एच कितनी, हमें इफ एच तो दे रखा है, मर्करी का प्रेशर हमें पता चला, तो हमारी इक्वेशन आ गई यहाँ पर देखो, रो वाटर इनटू डी इनटू जी इज इक्वल टू 7 टाइम्स रो वाटर इनटू जी इनटू एच, हमारा जी से जी कट जाता है, रो वाटर से रो वाटर कट जाता है, हमारे डेप्थ डी की वैल्यू आ जाती है सीधे सीधे 7 रो एच, 7 रो एच हमारा आंसर ये है, साथ में इसकी ऐसा यूनिट मीटर लगी है, तो काफी अच्छा सवाल था, काफी कंफ्यूजिंग था भी, और इसको पॉज करके एक बार फिर से सॉल्व करके देखिए, ऐसे सवाल आपको सॉल्व करने आने चाहिए। अगला सवाल देखते हैं, द कंप्रेसिबिलिटी ऑफ वाटर इज 4 into 10 raised to the minus 5 per unit atmospheric pressure, ठीक है, लिखते हैं कंप्रेसिबिलिटी इज इक्वल टू 4 into 10 raised to the minus 5 per atmospheric pressure, तो मैं इसको एटीएम लिख रहा हूं, और पास्कल इसको मैं ऐसे यूनिट में कन्वर्ट कर सकता था, लेकिन जरूरत नहीं पड़ेगी, देखते रहो, द डिक्रीज इन वॉल्यूम ऑफ 100 cm cube of water under a pressure of 100 atmosphere will be, क्या,
What about I like? I'm gonna forget everything I just learned. Yep, I definitely am. So what was that? Properties of fluids. Edited 17 videos. Are you like fucking kidding me right
वीडियो अपलोड कर रखा है स्टार्टिंग फ्रॉम इलेक्ट्रोस्टैटिक से लेके कम्युनिकेशन, 11th स्टैंडर्ड में भी हम लोगों ने ग्रेविटेशन, थर्मोडायनामिक्स हो गया, किनेटिक हो गया, गैसेस हो गया, देन डायमेंशंस हो गए, राइट, वन ईयर कैलिपर हो गया, स्क्रू गेज हो गया, तो बहुत से टॉपिक ऑलरेडी अपलोडेड है, राइट, और सभी के सभी एक प्लेलिस्ट में है, रिवीजन सीरीज प्लेलिस्ट लिंक, ये लिंक आपको नीचे भी मिलेगा, आप जाके इसको देख सकते हैं, और इस पीडीएफ में भी ये लिंक आपको मिल जाएगा, ठीक है। यहाँ हम लोग बात करने वाले हैं
My lips are literally bleeding. I don't think I can do it anymore. It's just I'm not even getting anything. You know what, guys? I'm just gonna follow what Gemini told me to do. Yeah, I'm gonna just do this. Ha ha. Now who's the winner of everything? I'm just gonna do these bad boys. That's it. Yeah. Pressure at depth. H equals P equals P naught plus rho GH. That's what I'm talking about. Not one single word more than this, dog. I'm like, God. I'm not a slave. Pascal's law that F1 by A1 equals F2 by A2. Yeah. Hydraulic lift. Pressure is equal in every direction. Oh my gosh, did you hear that? That shit low-key crazy. Why my armpits are sweaty? Like, I don't know. It's like so cold and I'm like still sweaty. I don't understand this, dog. Anyways, as I was saying, the Archimedes principle is that Archimedes principle by and force force FB equals weight displaced of the fluid. FB equals V in rho FG. I don't even know what that fucking means. What? V initial and density final? Is it something like that? I don't know. And I don't care. And now the hydrodynamics. Let's go. Equation of continuity. Equation of continuity. A1 V1 equals A2 V2. Okay. Okay. Now Bernoulli's theorem. Bernoulli's theorem is that P plus half rho V squared plus rho G H equals constant. Okay. Velocity of efflux, Torricelli's law. Torricelli's law. Velocity of efflux. Of efflux. V equals 2 root 2gh. Okay, the water coming down from the tank. Now viscosity, dog. Viscosity. Now viscosity. That's Newton's law, dog. Come on. Newton's law of viscosity. F equals beta A dV by dx. I don't know how to use this formula. Stokes' law. Stokes' law. F equals 6 pi eta RV. Terminal velocity. Okay. Eta. That one was like good. Okay, you know what? I'm gonna do it one more time. Beat T equals 2R squared rho minus sigma G upon 9 eta. That's great. Okay, surface tension. Okay. surface tension. T equals force by length. What? X is pressure? The hell? The what? X is pressure. Pressure. P equals 2T by R. Okay, whatever. Bubble. That P equals 4T by R. Or drop. Okay. I see you. I look so fucking. Capillary rise, yay! Now that's a good one. Capillary rise. H equals 2T cos theta upon R rho G. And that's it. Velocity is proportional to R. Is it? Okay, cool. Thank you. Thank you for telling me that. Can you like define all the terms for viscosity? Nurse area and dV is the liquid velocity and x is the distance. Okay, Stokes' law. The baller rule. What the fuck? The baller rule. If there's a ball, then it experiences a force, and that force is this. This is the radius of the ball. Okay. The terminal velocity. ML minus 1T minus 2, ML1, ML minus 1T minus 2 is the, yeah. Well, already, like, it's running out of battery already, though? Like, no. You cannot be serious. You know what? I think this is gonna work. Reynolds number, laminar flow. What the fuck? The fuck is this? What? Legally flow. If RE is like smaller than 1,000, if it's greater than 2,000, it's definitely okay. Thank you. I guess this is enough for NEET. And okay, thank you. Now give me some NEET numericals with answers. Come on. Now give me some neat numericals with answers. Tall. It's like too much zoomed in. Oh, wow. No, not on this, dog. Yo, what is this? What is this? Wow. See, I told you I'm gonna forget everything. You should eat something and take 1 to 2 hour power naps since you've been studying for very long hours. Yeah, you know what? Actually, I'm really hungry. Look at my eyes, dog. I look like a zombie already. I don't know. Um, I I should definitely eat something. It's like okay, you know what? I know I'm gonna like perform really bad in this test. So like, why should I even put efforts? Yeah. No, it's not like that. I still am putting efforts. I still am put. I still am putting efforts because I know. Because I care about this country. Oh my gosh, I can't impersonate Trump for some reason. I just can't. Anyways, yeah, I think I should definitely eat something. Yeah, because I'm like very hungry. Oh, I need to drink some water too. Because I'm very thirsty too, man. Sorry for burping. I said only from this. Oh my gosh. From fluid mechanics only. You know what? Let me just grab something to eat real quick. Guys, my brain kind of like stopped working, so I don't like, I can't get anything into my head. I don't know what I should do. Like, brain is not braining. I think it really needs some, like something. Okay, I'm like literally sleeping for like half an hour. Okay, guys. My brain is not braining. Like I'm like trying to study, but nothing like getting inside. So I think it's time for me to like finally take a rest. So we have like 1 hour till our 24 hours challenge completes. So I mean, I could like. So I could like spend this by taking rest because I haven't taken any actual rest. So what do you say, guys? What do you think? How should I spend this last hour? Should I keep revising or should I just take a fucking nap? I think I'm gonna take a fucking nap. Because I don't want to be brain damaged. Sorry for looking like a zombie. Okay, I know, I know. Wait. Okay, I know there's like a lot of background sound, like, but oh my god, it's been 24 hours, dog. Like 20 freaking 4 hours challenge done. I like can't like unmute for because like it's like morning prayers time, so there might be like prayers playing in the background, and if the prayers catch, I mean, if my stream catches the sound of the prayers, my stream will be gone. So, anyways, I'm like so excited. I completed the challenge, bro. I'm like so fucking. By the way, did you see I got like a bruise here? It hurts, like it hurts really bad. I'm like literally trying my best, okay? Okay, guys, so I'm gonna like end this live and I'm gonna get ready to for my test today. And I know I'm not gonna like score really well, but you know what? We can try, okay? Like we can try. Ignore them talking, okay? My grandparents are like talking. Anyways, so let's just give it our best and like just see what happens, okay? And see, I still got the bruise and it hurts.